if we've got, I suppose, as long as there's more than us three.
There's more than us three here.
We're on a winner, which is good.
Yeah.
Okie doke. Right, let me just get my, make sure my computer works. That's great. Okay. This isn't a podcast, so I don't need to do a countdown. Right. Hi, everybody, and welcome to today's Amendment 2 webinar. It's our first one of two. Yeah, thanks for joining us. I have spent the last 2 days with my good pals, John and Dave,
waiting for the book to arrive.
Well, luckily, I've been reading it for the last 2 days, creating these slides. Now, we were, as you are aware, on YouTube. There was a video we did in a live webinar where we discussed the proposals. And lo and behold, there have been significant changes.
Just for me to clarify here, in case you're thinking like, oh, everything was well prepared ahead and stuff, it wasn't. Mr. Meaden was at 1 o'clock in the morning, Monday morning, messaging me, hitting refresh on his vital source. Is it a gold subscription you've got, something, bud? You know, waiting for the publication to appear. It didn't appear until the morning.
Nope.
But
8 o'clock.
So a lot of this information has been looking at the digital version on the online subscription. The paper versions weren't in our hands until today, or some of us.
I'm not going to lie. I've had about 6 hours sleep since Sunday night. And yes, I have been reading both books meticulously. I have been watching the IET webinar, which I thoroughly enjoyed, and the Eton one, trying to digest different views and opinions. And that's what this is about today. It's about views and opinions and us debating this as three friends, as three engineers, as three guys in different parts of the electrical industry, but also to debate it live with people. So if you're watching on YouTube, I'm really sorry. We can't put the chat in YouTube because I don't have the competence. So blame me. All right. Yeah. So what we're going to do is we're going to get on and we'll just start progressing because I have no idea how many people are in here. So let's start off by thanking our sponsors.
Oh, wow, that's great.
Yep, there we go. So that's our sponsors thanked. Anyway, so I've always wanted to do that, and then I just realized we don't have any sponsors. But this journey of ours in the industry, it just keeps on continuing. For anyone new to the electrical industry, if you think for 1 minute that this is boring, you're wrong. You're in the wrong job. There's nothing boring about this industry if you commit to being keen and passionate about learning and leveling up and being at the forefront of being the best you can be. And obviously this is a dangerous industry as well. So obviously we all know by now it's out. We got the big brown book and it was issued yesterday. We can implement it immediately, although good luck on implementing it immediately because it's quite a few hundred pages. But they are expected to comply installations by the 28th of March, 2023. Now that was in an IET article. Weirdly enough, Amendment 1 is withdrawn on the 27th of September. So there's a little bit of confusion there, and I've highlighted it on the slide. Either way, there's normally a 6 or 12-month grace. You're expected to comply. Remember saying, it's down to you. You own the risk. You can depart. This is a guidance note. It's a guidance note that is seen to be complying with the law. You must be competent enough to be able to stage your own defense. Don't be afraid of a book, okay? Because there's been too much conflict in our industry about a book and its godlike status. It's a British standard. It's a guidance note. Just on that, before we get into the thoroughfare of what the changes are, me and John, we love going back in time. We love looking at old regs books. We'll do some more on the past editions. I just find it really interesting that in the 50s, there was 212 pages. John, what's your thoughts on the ever growing and changing?
Yeah, well, so this thing about a new book coming out every other year, it's not new at all. This has been happening literally for decades. And with a few exceptions, most of the ones that come out have more pages in. And some of them, well, certainly from the 15th edition, the pages got a lot bigger. And since then, it's just been more pages and more pages and more pages. So although they seem to have to buy a new one every 2 or 3 years, it's not actually that new. And if you went back to, say, the 1960s, if you bought them in the 60s, you'd have to actually buy 7 of them in a single decade. So just be glad we didn't have to get into that. So the 15th one at the end there, that was the first one, which was actually A4 sized. 1981 that came out. That was sort of the first of the modern era. All the ones previous to that were little half-sized books. And that sort of leads on to where we are today. So that's the one you're probably more familiar with. So that's the 17th one there, just shy of 500. The 18th busted through into 500 plus. And now with Amendment 2, the brown one, we're now over 600 pages. And they've added another sort of 50 odd pages to that, with lots of bits taken out and changes and amendments. So yeah, it's a new book. We all like to complain about buying it, but ultimately nothing new there. Been going on basically since it was published in the 1880s. So.
Yep, it's always interesting to see it grow. And just remember, in case you're wondering, if you look at the American book, that's over 1,000 pages. The Irish books are well over 700. It's going to get bigger. It's just got to be honest with you. It really does. So that's kind of where we are at the moment. You can see the journey, how many parts and it's growing into. And for those who are learning, who need to understand a little better, who are at the beginning of their journey, 7671, the big blue book, was divided into 7 parts: introduction, definitions, assessment of characteristics, protection for safety, selection, erection, inspection and testing, and special occasions. And we're now at 8 parts, which just adds functional requirements, which is chapter 82. Would have been chapter 81, which would have included energy efficiency, but I think we made some fundamental mistakes rejecting that and allowing it to be an appendix, but we'll come on to that. Before we get in, one of the first big changes or notices that you see at the start of the book is this. I call this the Paul Skirm page, pretty much because our Welsh friend who is still suffering from cancer, this is what he consistently berates us about, and that is the correct use of verbal forms of engagement and understanding. Like in the electricity at work reg, shall indicates a mandatory, a requirement. In the wine regs, they've given us this wonderful little table which just explains what a recommendation is and the requirement term, what permissions, possibilities, descriptors, and it gives this term normative and informative. Now 7671, if you look at the appendices, anything that is a normative is a requirement of the standard. Okay, anything that's informative, like the appendices at the back with the forms of certificates, they're informative. That's a guide. You can choose to use them, which is why the NIC have their own certificates, or Electroform do, or other people. You work from those requirements and interpret how you want. But don't forget, all of this at the end of the day, it's a guidance note. It's very got to be very clear on that. So let's get into part one, some of the changes. Now, what we thought we'd do is try and highlight as much as we could. Some are very minor, little fickety things. Others are quite major, but you guys pick and choose. So first thing, in the scope of what's included in 7671, item 4 includes this new term, prosumers low voltage electrical installation, including those located to external buildings. And in the background, you see a prosumering, consuming and generating building. We will come on to that later in section 8, but prosumers are now in 7671. John.
Yeah, this is 11012. We're actually adding to, as we've got there, the bit in green is what we've added. So it's including installation and support of fiber optic cables. So that's going to cover like your broadband and all that kind of stuff as well. And this also applies to things like premature collapse and all of that. So no slinging it over the top of the suspended ceiling to those data installers and all that. So that is now in 7671.
So that's another good point, John. So if you're a client, if you're a person ordering the work, if you're an engineer, if you're a manager, how many people on comms installations get a minor work certificate or an electrical installation certificate for a data installation? They don't. Realistically, it's covered under 7671, as are the requirements of premature collapse, cable management, etc., etc. The installer should be certifying. Now, this was just included, I believe it was because there was some conflict and rows and debates over what exactly communications or this sort of ELV wiring was. So they've included fiber optic cables because it was just easier to put it in. But effectively, if you're installing comms, treated no differently from electrical in every way, yeah, it's cable. Moving on, this was a mistake in 7671. It's always had explosive atmosphere standard. What they've amended it in the Brown Book to say series, because if you ever look at 60079, there are lots and lots and lots of standards. So anyone who works in ATEX or Compex, whatever you want to call it, that highly explosive environment, There are very much additional requirements in other standards to ensure petrol stations don't blow up and refineries, etc. So it's identifying that there was a series of them. So it's an error that they've corrected. And I'm going to say this out loud. I think the Brown Book is an improvement on the Blue Book. Yeah, that's kind of my initial summary on it, really. Go on, John.
Right, this is exclusions. The bit in white was always there, so it doesn't include distribution electricity to the public, but it now does include prosumers installations, which are covered by Chapter 82. And this is the sort of thing where you're going to have battery storage in your house or solar, which has potential to supply energy back into the grid. So that is within the scope, but things outside like the distribution network are currently not, just as they were before. And we'll cover that later on when we get to part 8.
John. So it is in, but it isn't in, but it is in, but it isn't in, but it is in, but it isn't in, depending on how much we're prosumering. So
it's quite a fine line, isn't it?
Oh,
there's going to be a really weird line to draw between the two.
Yeah, absolutely. So yeah, this kind of means that when we're looking at these sorts of installs, which if anybody's watched our DNO webinar, you'll remember these images. Do we code an electrical installation where pitch is leaking? Do we code one of these wonderful TTCN-SCS installs? Because technically they're out of scope, and they always have been. So it leads a question about coding, but we will come on to that later on because we found something that nobody's spoken about yet. So please stay tuned for part 6. One of the things that I wanted to put in, because I'm of an age where I remember dual colors coming in and all that, direct and indirect is the term, shock protection is a term that I grew up with. It's what I still use today. That has now been completely removed from 7671, and it is now basic and fault protection only. So if you use those terms, you're going to have to stop, unfortunately. And I think, Dave, you nailed it before we went on air. There's a lot of stuff that has been retired from BS 7671 in this edition. So for those over a certain age, maybe 40.
It's like the 16th edition stuff, really. Stuff that was there in the 16th edition. And then when we come over to the 17th and now to now, I think how long ago that was. It's, you know, you're getting near 20 years at that point. And a lot of that stuff has long since retired, even though we still talk about it, even though some books still use it.
Yeah, I agree. And manufacturers will as well.
Yeah.
So this is, if you don't mind me saying this one, John, sorry, 121. So one of the interesting things I found in reviewing this is the use of the term rules and various other terms that have been scattered across the document. They've now changed it. They're not referring it. What they're trying to do is harmonize the language they use. So what they're now calling it is BS 7671 contains requirements, which I personally think is a far better use of language. The only thing I wish they would do is change the naming of the document, because the title of the document is requirements for electrical installation and then regulations. I'd just like it to be called regulations or whatever. But that's the harmonization that I think they're doing across the document, which I think is an improvement, getting rid of all the scatty narrative and just having a common approach for this standard BS 7671. So that, I think that's a good thing. Moving on, part 2. There are new definitions introduced, which aligns with this huge encyclopedia you can purchase if you wish. IEC 650. There are dozens of parts in this suite of standards, and it's a harmonized international electrotechnical vocabulary, which is why we'll see more and more terms changing. Even there are standards for maths, by the way. There are IEC standards for maths, harmonized maths, electrical maths. So there's a lot of these standards. John?
Yeah, that particular standard, by the way, you can obviously buy it, or
Yeah.
if you go to electropedia.org, you can search it and view it for free. So all the definitions on there. Oh, well, now you do. Yeah. Electropedia.org, which is it's basically like an online equivalent of it, so you can.
I've ended up on there an awful lot when I come to have standards that have mixed. You know, they use the same term from different things, and I need to know exactly what the term is for, because a lot of standards use the similar language, but they use it for different perspectives. And the Electropedia site is a great way to actually get through all that nonsense.
Yeah. So that's the official definitions of things, which may not be quite what you expected, but That's the one that you're supposed to use. So,
And John's giving you a link for it. Well done, John.
yep, it's in there. So that's it.
I didn't know. I've learned something new on my own webinar. God bless you, John.
Oh, there we go. So, yeah, this is part 2 with the definitions. There are various new ones here. A lot of these relate to part 8, and there they all are in green. So it's mostly to do with prosumers, electrical installations. We also have some nice things about foundation earth electrodes and efficiency measures. That's all in part 8 as well. And we will cover this later on when we get to the part 8 bit.
Indeed.
But yeah, there is a lot of these. So we're not going to go through individual ones, but
it was
nice to
interesting to
say.
see AFDD, John, in there, defined. That was the first time it was defined,
Yeah.
AFDD, which was interesting, considering it was in the 17th edition Amendment 3 as a teaser. And I'm sure there's more stuff that's buried in here as teasers as well. Right, moving on. Consume unit has been updated. So now we raised this in the DPC, and I'm pleased to say that it has changed, but it's not. So a consume unit is currently defined as a particular type of distribution board comprising of type-tested coordinated assembly. So that's what it said in the Big Blue Book. For control of distribution of energy, principally in domestic, incorporating manual means of double pile isolation in the incoming, and assembly of one or more fuses, circuit breakers, RCDs, or signaling or other devices proven during type testing. So it's now, under the Brown Book, a particular type of distribution board intended for operation by ordinary persons. So it's considering the utilization side of it. So operation by ordinary person, would you let someone near rewirable fuses? Are they instructed? Who knows? Compromising a type-tested coordinated assembly for the control and distribution of energy, incorporating manual means of double pole on the incoming circuit, and assembly of one or more protective devices, signaling and other devices proven during the type test assembly. So they keep banging on about type tests, but they've removed fuses. So I'm taking this as our fuse boards, as in old-fashioned fuse boards and rewirables, now not defined as a consumer unit anymore, and hence are they compliant?
Yeah, that whether that was the intent is another matter. That's certainly what it suggests.
We're trying to get.
They're probably in the office going, "Oh, for God's sake!"
Yeah, bloody hell, Meenan, what's wrong with you?
But the important thing to add with that one is it does say type tested, type tested, type tested. So if you do decide to swap devices from one manufacturer to the other in your consumer unit, it might no longer be defined as a consumer unit.
Well, it won't be, because the type minute they brought this type test row in, and that mix and match stuff, and now under this they've just said, well, it's not a consumer unit under the standard.
Exactly.
The defined definition, it's not a consumer unit. Moving on, JW.
Yeah, this is DSO, which is distribution system operator, which unsurprisingly is a party operating a distribution system. Previously, you're probably familiar with this as DNO. It's moving to DSO because it's not just a network anymore, it's a whole system of dozens of parts, and we'll see more of that later as well. So DSO is effectively what DNOs used to be, but it now covers a much wider scope and covers a lot more stuff, and it's going to be all fitting in with the prosumers and generation and shoving energy back into places it was not intended to go and all of that.
So just for anyone watching who's of a certain age, DNO started off as a regional electricity company. They all had their own acronyms. So LEB, London Electricity Board, Eastern Electricity Boards, Southern, Seaboard, Northern. So they all had their own names. That's obviously, if you watch our DNO EICR coding webinar, we do go through all the DNOs and how they're changing. And we have been predicting for many years this DSO stuff. It's not new, but what it does appear, John, is they are actually kind of keeping the DNO term now. DSO will sit above them as a system operator, and the DNO will become the local operator, which is just more carnage.
Yeah.
But let's show you what it is, because I have to thank UK Power Networks because they made me thank them. And there is a link on the screen, if you screenshot that, to their, and I'll put it in the YouTube video, to their Future Smart Consultation Report, which they've very kindly allowed us to reproduce. John, it's the changing world of electricity.
Yeah, these, so you can download these to have a look at in detail. This is the old world. And we're saying old, it's not even the current one anymore because we're partly through this. So this is what used to happen. basically you had your big old power stations, mostly which burn coal, large-scale generation. That went into a transmission network, so that's your pylons and cables all over the country. Gets down to a local level where you've got more sort of local distribution, smaller size stuff, basically, and then it ends up in the customer, so in your house.
If you remember,
Simple.
If you remember when you go back to college, there was always a line, wasn't it? Generation, up the voltage, transmission, step down the voltage. It was always a line. That drawing.
Yep.
Well, let's
So-
show you the future, shall we? If it works.
It's broken.
If it works. I've broken it.
You're breaking. There we go. Well done.
Hey, so this is the new world, and by new we mean pretty much happening already, because most of this stuff already exists. So we've still got large-scale generation, but as well as your traditional power plants like your gas and coal, you've also got things like wind farms and solar farms. We've now got things like battery storage, which though aren't generation specifically, they'll take power in, obviously put it back in later on. Transmission, of course, it's still there, both on a local and larger scale. However, at the local level, we've also got local generation. So you can have solar generation, say, in a massive field somewhere, which is another topic altogether, but you've also got things at a more local level. And then you've got all of this other new stuff. So you've got your houses with solar panels on them, wind turbines in the garden, quite a lot of them have batteries in them now as well. You've got electric vehicles fitting into this. And the most important thing here is it's not just one way anymore. It's just one big loop where all of this stuff is all connected together. Power can literally flow from one to the other in multiple directions. And it's just massively, massively more complex.
Fundamentally, the demand isn't always at the end now. It can be at different points, and the power will go either way.
And regulating this is going to become incredibly important, henceforth the rollout of smart meters, but we'll cover that later. Right, part three. Part three, huge changes.
I'll do part three.
Yeah, okay.
Oh, well done.
That's good. That's good.
Yeah.
Moving on then. Yeah.
Yeah, not really much there at all. Minor stuff, minor.
Yeah. Changing a full stop and a capital letter and moving on to the next part.
Well, right, so part four's got some changes, and this is where we get the butter on the bread. So this is, if we all remember 411312, because we all memorize the regs, well, Mr. Betteridge does. I used to when I was younger. It had a nice little regulation everybody should be familiar with. Each installation will have bonding conductors. They go to metallic, water, gas, etc., etc., etc. And it then said in the blue book, metallic pipes entering the building having an insulating section, which did drive some interesting and amusing pictures like that, where we would go on Instagram and have the names Bond, pointless Bond, as part of our fun and games. It's now been reworded in the big brown book. Thankfully, it's the BBB. In each consumer's installation, so that's a nice little change there. Within a building, extraneous conductive parts liable to introduce a dangerous potential difference. And that's a new term, dangerous potential difference, because you can get potential differences. I can get my mega out and go on somewhere at work and I can read voltages, but will all be 4 or 5 volts, and that's fine. It's tolerable, but depends on the nature, utilization, the system, what's being leaked to earth, what the local network conditions are. So it has the same stuff to be bonded. It then has just rewritten the as a note where non-metallic pipes, plastic enter the building, are then connected to metallic pipes within the building. The metallic pipes within the building do not normally require protective bonding. And then right at the end of the regulation, I haven't quoted all of it, there's a requirement for incoming telecoms cable, which I think we as an industry are terrible at, mainly because the telecoms industry is generally, in my personal experience, utterly terrible to deal with. Never mind surge protection of these sorts of things. But what it does do is it talks about getting consent to bond. Let's say you've got a multi-core cable coming in for telephones or whatever, and there is an exposed or extraneous part to it. We need to get consent to do something with that as far as bonding it. But it then adds, where consent is not granted, as a consequence, this requirement is not met, details need to be recorded on the certificate. And that's another thing that comes in this regulations, ensuring that we're defining more and more departures and more issues on the certification.
Yep. Before we move on, I'd like to bring one of the questions that's come in up, as it's right here that it's about. This is from Mark. And it's great that he's thought about these questions before he's come in. So, liable to introduce a dangerous potential difference. Is the word dangerous new, and how is it quantified?
Good question. I watched the IET webinar, as Mark probably did earlier on. Was it today or yesterday? I can't remember. It was yesterday.
Yesterday morning.
And they spoke about this, which is one of the reasons why I highlighted it, because again, listening to your peers is always a good thing. For me, potential difference is just voltage difference is what equipotential bonding is for. Dangerous, in my opinion, is a dangerous term, because what you're now doing is you're saying I can tolerate certain voltages.
Yeah.
If you look at G12, I'm going to use railways as an example. G12 doesn't allow a touch voltage on railways above 25 volts. And there's a reason behind that. I don't know what dangerous is. I am assuming that there is something in a new guidance note that's yet to come. So we'll probably cover this in a future podcast.
Yeah, without any other instruction about things like you say 25 volts, if there's more increased risk, if the person's in like a wet room or a location like a bathroom or something, you'd have to assume, and that's a dangerous word as well, that we're talking about the point of ELV to LV, the 50 volts or the 120 volts AC and DC, because that's what we would do with 415.2 with supplementary protective bonding. We'd do it to ensure that was the voltage we must not go over. With all these other protective functions, that is the point that we must not go over. Unless they give us a more definitive, no, it's actually 25 volts. I'd have to go with that, with my own initial opinion of that. But again, if it could be that I could engineer it, so it's got a 38 volt touch voltage, but it could be that the way they use the system, that's still dangerous. It's a very dangerous word.
So for everyone in the chat, as you can see from that photo, that's probably an unnecessary bond unless that water main goes through the wall and is still under the ground and then comes up again. Then yeah, it'd still be wrong anyway. But let's look at something that we're not thinking about, and this is a warning. This is the stuff that industry bodies don't tell you, but we're going to tell you. So this is MLCP pipe, which is one of newfangled flexi plumbers, push fit, la 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 la. But some of these pipes you can get are aluminium reinforced, which means there is a chance and there is a potential to travel down it. Now, the reason I say this is because obviously I work on railways. We've got 25,000 volt lines, and there is a chance that running insulated pipes, you could have a coupling effect. You can get transient voltages, etc. And depending on the magnitude of it, you could actually get, if a plumber installs it wrong, this becoming conductive pipe when we all think it's insulating. So the only reason I've put this in here is to just make people aware, even if it's plastic looking, test the damn thing. That's it. That's your warning. Can't say you weren't told. Moving on, 411313, additional requirements for socket outlets for the supply of mobile equipment for use outdoors. This is an interesting one because it says RCD not exceeding 30 milliamps shall be provided for socket outlets up to 32 amp, which went up to 32 amp in the last edition, i.e. the 18th. But it adds in locations where they're liable to be used by persons of a capability BA1, BA3 or children, BA2, BA3. It then also adds, and this is a new addition to the regulation, mobile equipment of a rated current not exceeding 32 amps. So they're really closing down on everything up to 32 amps, RCD. That's your blanket. There is an additional note 1, that says for the purpose of the exception, an ordinary person instructed in the use of the installation does not become an instructed person. Now, that was an interesting one that was debated on the IT introduction. I have taken that as basically I can't instruct someone, as long as you don't put, I don't know, I've put you in an RCD socket, a non-RCD socket for a fridge, but just don't plug anything outdoors. That wouldn't be acceptable anymore. So because they're not electrically minded enough to be able to follow that instruction for the life of the installation. There is obviously an exception to 2 and 3, which is socket outlets in locations other than your domestic areas, but you've got to have a documented risk assessment. And the documented risk assessment has got tighter and tighter and tighter because they don't want you to do it, which is fine. And they don't want you to have there is a permission to have non-RCD where there is a suitably documented risk assessment with the involvement of a skilled person. So an electrician or someone with necessary electrical skills will determine it's not necessary. That to me is a brilliant standout regulation now, because if you have control of the utilization and the risk of it, then you shouldn't have a problem writing a risk assessment. If you don't, RCD it. And just if you're wondering what the BA codes are, BA1 is ordinary persons, BA2 is children, BA3 is changed from handicapped to disabled. And yeah, that's kind of your codes in there, really. So thought it was small but really important. So the risk assessment stays, but you better have a damn good risk assessment, and you better know what you're doing and all the rest of it. So
yeah, this is not an excuse to try to just avoid, save money or avoid using RCDs. There has to be a
It has to be a really good reason.
Really good reason.
So this is a bombshell that nobody's spoken about yet, and I don't know why. 41142. For TN systems, it's recommended that an additional connection to Earth by means of an earth electrode in accordance with Chapter 54 is made to the main earthing terminal. This recommendation does not apply to outbuildings or dwellings served by the installation. Okay, guys, come on, John, what do you think?
Yeah, this is a thing that they've tried to put in before in several previous draft things, and one of them said you will put it in, and it could put it in, and you might put it in. Just to be clear here, we're talking about a TN system, so this is not a TT thing where you're putting in the electrodes. This is a TN, so it's TNCS in most cases, or possibly TNS. The point of this is to put one in so that in the event of certain types of fault on the network, it will keep the voltage on the exposed parts down to a sensible level. Now, it says it's recommended, which you could take to be, well, we can't be bothered, but in reality, recommended means you should be putting it in. And this is just putting an electrode in, connecting it to the earthing terminal. In terms of how it works, it's no really different to having the, say, older installations where you had your metal pipes coming in and they were bonded. Although those weren't earth electrodes as such, they were acting as that. But of course, now with plastic pipes and all the rest of it, we don't generally have metal pipes coming in. So this is kind of the replacement for that. Earth electrode can be nasty old metal rod you ram in the ground, or things like these discs we've got in the picture there. So although it is recommended, put them in. At some point, it's going to say you will put them in. That is pretty much.
It's not. Yeah, it's going in that direction because, as you say, we're taking so many of these other electrodes out of the building now, or these byproduct electrodes out of the building, and we need this.
The big arrow in the comments there, 20 ohms. Yeah, it doesn't actually say what resistance you're supposed to have. It just says put in an electrode. So yeah,
I can answer that. So Pete, you'll have to watch our next podcast when it answers, because we do actually go through it. We haven't recorded it yet, by the way. We'll record that probably this weekend, but watch it because we're actually covering maximum earth electrodes and PME and G12 and all that malarkey. So it's in G12, but generally 20 ohms, yes. So obviously, we all know that anything above 200 ohms, the saw can be considered unstable. Anything that's below 20 ohms is good for PME systems to remove step voltages. Okay, and that's in a lot of the ENA and DNO documents. They haven't worked their way into 7671. Sorry, Dave, you want to?
No, and it goes without saying that, I mean, a lot of this kind of carries on with the legacy of electrodes being just rods or just being tapes and plates and a bit troublesome to install and manage and predict and control. But as you see, if you watch the recent stuff that we've put on the E5 channel, you see there's lots more developing in the world of earthing. And so the number isn't impossible.
So there we go. And that's why we're showing the conjure discs, because I've used them. That's my installed stuff. And yeah, they're far better than rods. So one other thing, and this is controversy now. I don't want it to be deliberate controversy, but I'm going to say it. This is a precursor to mandatory earth electrodes for every installation. We know they do it around the world. It's coming. Now, everyone can argue it's a good thing because it lowers your local impedance. However, what this does as a side effect is this masks a high resistance pen joint, because what you're doing is giving a low impedance earth electrode reference for network currents to flow down and into. And that makes it very difficult when we're prosuming, when me and John will talk about that later on, and we're doing switching of earths and everything else. So this is good in one breath, but if you put this electrode in and you start getting current flowing down it, then it's masking the hazardous effects of a broken pen. That's really dangerous. Now, it's good for the networks because it means they save money. So I'm not a fan of this regulation under the context, but we will move on.
I'm a fan under the context of it being a electrode for an island mode, but not from the context of it actually
indeed
covering up this other issue.
Very good point, sir. Right. AFDs, I'm going to speed up a little bit because we've got a way to go. Protection against shock. AFDs conforming to 62606 are recommended. This was in the blue book, and we got this carnage. It's the only word we can use, carnage. AFDD hatred. We even flew to Austria to meet them and talk about them. We know they work under certain conditions. So that's just a single module device. We know there are issues with single and double and triple modules, but we're not going to go into that now. So there was requirements for sleeping accommodations. I thought they were okay, but it's still called carnage. So let's give everybody the blessing that they needed if this works. But before we do, we'll discuss what an AFDD does. John, over to you.
Yeah, that's the name suggests. It's an arc fault detection device. Arc faults, there's two types, which is what we've got here. On the left there, we've got the arc between two conductors, so line and neutral in that example. And on the right there, we've got just an arc on a single conductor. So on the left, it's called a parallel arc fault as it's across two conductors. And the other one is a series arc. It's basically where conductors come apart and it's just arcing between the two ends. What happens with these is that the electrical energy will damage the insulation, carbonize it, which makes it more conductive. That means more current will flow, and then it gets hot, and then it gets more damaged, and it's a sort of endless cycle until flames and fire come out of it. And the idea of an AFDD is it detects this before it gets to the flames and fire coming out. So it would disconnect that before it sets fire to your house or office or whatever else that you've got.
However, the level of energy under the standard that can be detected as it stands is 2.5 amps, apologies. So anything below that, I know Wilex say that their device detects arcs of 1.5 and above. That's great. This is one of the key considerations that's got to be made when selecting these devices. Obviously, there's some more images of what it can do. You'll be all very pleased to know that these devices and the standards committee that wrote the product standard are actually responsible for white goods. So it could be discussed that rather than installing an AFDD in each unit, it got thrown over our fence and we have to install them. But I think AFDDs are a good device. I think they do work, but certain conditions and criteria must be met. One of the more recent developments, and we would be wrong not to say it, is one of the good risk mitigators of removing the need for AFDD would be to use LSOH cabling. John, you know why?
Yeah, LSOH, if you've ever used it, it's a horrid cable to use because it's difficult to strip. But the main point of it is when it gets hot or sets on fire, it doesn't give off toxic smoke and it doesn't carbonize in the same way that PVC insulation does. All that happens is that the insulation basically sort of melts, turns to a liquid and disappears. So there's no actual arcing parts there other than the conductors themselves. So unlike PVC, which will char and blacken and get worse and worse and then become conductive. So that kind of cabling is very likely to be a thing, certainly in these high-risk environments.
So this is what the new reg says. AFDD conforming to 606 shall be provided for single phase up to 32 amp. And then it says in high-rise residential buildings, houses in multiple occupation, purpose-built student accommodation and care homes. For me, far more succinct, far more sensible.
It's a good start.
It's a good start. It is a very good start.
Remember, there was a care home a number of years ago where a number of people died. And you know, it wasn't multiple stories. It was just a normal care home, but with the challenge of actually evacuating the tenants, a lot of people died there.
However, I'm going to be a however here now. If you want to reduce risk as much as reasonably practicable, okay, if you wire that care home in LSF, twin and earth or singles, you've removed that risk of fire developing on a series or parallel arc to an extent. And also you then need to look at magnitude of energy level on that circuit. So if you've got a radial circuit that go to, I don't know, Granny Smith's room and she's got a new telly and everything else, there's not enough load there to actually generate an arc. And if she does plug in, say, a floor heater or whatever, then the only real PVC is going to be on the flex of the cable. So these are the sorts of mindset considerations we need to be considering. Now, there's a great note that defines high-risk residential buildings are assumed to be residential buildings over 18 meters in height. So buy a laser measurer to measure the height of these buildings, or excess of 6 stories, whichever is met first. Is anticipated in many areas high-risk residential buildings will be defined in legislation. So this one is subject to change because post-Grenfell, as you can see, they're updating the regulations to try and anticipate future needs. One of the other questions that I've seen, houses in multiple occupation. This is, to me, is a house that's been converted into multiple flats. That's how I see it.
Yep.
If I was doing an EICR, because I see everybody in the chat is asking questions rather than the chat, please ask the questions in the question, not the chat. It just makes it not lost in translation then. Our AFDDs, Nigel Dalton said, are they going to be retrospective on EICRs? You can only advise assessing against the current standard. So you may wish to say in a high-rise residential building, C3. However, Mr. Dempsey, God love him, who will be joining us again on some future podcasts, he gave me a great scenario of AFDDs. And it was simple. And he said, I go into a person's house, a local authority house, it's a council house, and one member of the family lives there and the other is bedridden. Okay. So Ryan has had cases where people have died in flats who were bedridden from electrical fires. Okay. So for him, why wouldn't I fit an AFDD? Just why wouldn't I? And he's right. If you have that vulnerable person, if you think about the utilization, can they escape? Think the big picture of how this installation is going to be used, not just, oh, it's not high rise, so I don't need to do it. I mean, it doesn't say railways on there. Luckily, I wouldn't use railways as an example anyway, but think about the utilization, think about the needs of the people there. More importantly, lighting circuits. They're not going to pull enough, or will they? You need to make a local assessment of what you think is a suitable level of protection. Coding, down to you. As it stands, they're still a C3 for me. And just remember something, they use energy to run these things. So I wouldn't put them on my lighting circuit because I know my energy is low enough not to warrant wasting the energy. Okay, but I think in 10 years' time, when we get to say 19th edition Amendment 2, these will be a C2, they'll be a mandatory, just like RCDs are now. And I remember when RCDs were supplementary protection.
And don't forget, they'll be a lot more affordable by then.
Indeed, and there is a little bit extra to that regulation. For all other premises, the use of AFDDs is recommended for single phase supply and sockets. So all other premises. So as I said, they're still optional for me in my house. However, if I was disabled, I would expect an electrician to come in and say, right, I'm putting these in to protect you and your home.
There was a question that's just in the chat there. I expect a few people have had this asked a few times, so let's just discuss it. Ring final circuits, AFDDs work fine?
Yeah, they do. Well, they do. In certain, it depends on what kind of fault you've got. If you've got a parallel arc fault, say between line and neutral, it will work just the same as on any other circuit. If you've got a break on a single conductor, say the line, then it won't. But on the other hand, it won't, because if you just break a ring, there's going to be a very tiny current there in most cases anyway. So there isn't actually anything to detect. Obviously, rings have their problems and things with being broken bits and overloading the conductors and all that anyway. But in terms of series arcs on a ring, it's not going to detect it, but then there's not going to be that amount of energy there to cause a fire anyway. So it doesn't
matter. The structure of the ring itself kind of gets rid of that issue, doesn't it?
Yeah.
However, if you have a connected load that's pulling more than 2.5 amps, say a fridge or a heater, or
an extension lead,
a series arc on the extension lead plugged into the ring, then it should, in theory, still work. So I think Eaton's words to us when we met them was, we don't recommend, because they won't give full performance guarantees that people would expect. And again, it's down to the selector and erector to consider all the variables based on the utilization of the home, based on the enhanced fire risks, etc., etc. But yeah, so I see this as a far clearer and better way. And there's probably loads of people going, behave yourself, Paul. But I genuinely do. I think it's a lot better than what we had. Right, now there is a whole new section on precautions where fire. Now, Mr. Dan Jackson can't be here tonight. So I'm going to do my worst impression of, no, I won't do an impression of him. We'll just crack on. So 422 has been completely redrafted, rewritten, changed, amended, whatever term you want to use. And it now covers precautions where risk of fire exists. It's a very controversial one. So what this does is it opens our eyes up to the world of fire. Now, the IET made a statement earlier on about we can't be expected to be fire engineers, but we are engineers who what was it you said earlier on, Dave? We go through all sectors, all levels, all homes, all areas. Everything runs on electricity, so we have to have an appreciation.
We're not a tribe in the corner. Our work gets involved in all the other, it conflicts all other people's works.
That's right. We give energy to everybody, so we have to have an understanding of this. And again, I'm not saying you have to be fire engineers for those people who want to criticize. I'm saying appreciate this, because this is based on people's deaths, firemen, people in flats. There's a reason behind this. There is a moral reasoning to get us to level up on fire safety. So don't fight it, go with it. It's a good journey to be on. So the requirements of this regulation should be applied in addition to those of 421 for installations and locations where, so 41 was AFDD, where the conditions of external influence in 422, so it refers to more regs. For such locations, fire safety design of buildings. This is a new thing post Grenfell. However, it isn't, because Part B of the building regulation has been out for decades. So has BS 999. So of all these other standards that people have completely ignored or did not know existed. Okay, so fire design and fire engineering is, I've always said fire risk assessment is on an existing building, which it is under the reform order. Fire engineering is the application of all these principles and standards to something new to make things better. So this information should be included in a fire safety manual produced by or for the person responsible for the building. So an electrician may ask for a fire safety manual for a building. If it's a rented accommodation, they most likely won't have one, but your output will end up going into it. Okay, just think about how that can make your business more attractive to potential clients to comply, because all of what you're seeing in here today, think of it as an opportunity for your business to grow and develop and make more money for your family. It's the best way, not going mad, really. So yes, the responsible person is identified in the fire reform order, which is a free to download document. It's been the law since 2005, caused a lot of chaos, but it's very black and white. And also in your local or national fire safety legislation or guidance, gives an example of BS 999, as you can see on the top right. BS 999 is the fire safety and design management use of buildings. It's commercial industrial. 9991 is fire safety for residential buildings. 9992 is railways. So if you Google BS 9999, you'll get a whole series of different fire standards. You've also got a qualitative risk assessment tool for fire engineering, which is 7974, published documents. And all of these can be picked, whether it's Part B, the reform order, 7974, 9999, 9991, 99992. So you go to that pool of knowledge and requirements and you pick and choose. Now, that's great to know, but we need to know how we contribute towards that. So it is recommended that the electrical system designer installer, who may not be a fire engineering expert, provides the person responsible for the building with details of the electrical system, which he should be considering all the fire safety requirements in 7671, setting out the basis of design with respects to fire safety, premature collapse, compartmentation, fire resistant cables, life safety services, which then leads you to BS 8519, which is a brilliant document, including routine maintenance. Again, more mainly commercial, industrial, or places where there's a client owning the building. Where it is determined that cables should have an improved fire performance but are not covered by regulation 422.2.6, this may be achieved by cables using a minimum light transmittance of 60% when tested in accordance with 61034-2 and are limited flame propagation to another series of standards, and where cable management to 422.3 and 4 are used. Cables should conform to the minimum requirements of 60. God, there's a lot of numbers in this, isn't there? Basically, in a nutshell, from what we've seen, is I don't know what 60% transmittance is because I don't own that standard. Forgive me all. I don't own that standard. But what I have read is effectively fire rated cables and don't use plastic trunking. Especially in a new term that got introduced, protected escape routes. Now, this means pretty much most protected escape routes are non-compliant on buildings. However, I have seen railway stations designed with this in mind. Lifts installations are designed with this in mind. So don't put a service in a lift installation where it's not meant for the lift. Same principle. Yeah. It basically states cables or other electrical equipment shall not be installed in a protected escape route unless part of the essential fire safety system, general needs lighting and emergency, or there's socket outlets provided for cleaning or maintenance. So if it's not relevant for that area, don't have it in there. A lot of social housing has submains running through these areas, all sorts. It's going to cause chaos. But again, these are recommendations. This is guidance. If you work on let's say a 10-story tower block and everything's wired in, I don't know, armoreds, 25 mil armoreds from a rifle board all the way through a corridor. As long as you've got fire rated fixings, yeah, you're still not necessarily, okay, you're not fully compliant with the intent of this, but you do have a level of compliance. It's about planning the next phase for when you do your next rewire. Am I going to be using fire rated armoreds? Yes, of course it will be, because there's been changes to regulations. It doesn't mean you go and rip everything out. This is improvement required. In my professional opinion, these are C3 things. Fire rate fixings ain't, just to be clear. I'm a C2 man every day. So guidance is provided in a new appendix. There's an entire new appendix called Appendix 13 that gives you some information. Please read it. It's really important. There's also an additional note that says generally cables in protected escape routes should be limited to lighting and associated accessories, emergency lighting, fire detection alarms, although cables for other safety systems may be necessary. If you have, I don't know, fire rated feeder that does fire alarm panels on each floor or whatever, you know, ventilation extract, you've got to be practical with this.
Yeah, it's definitely not like, oh, a regulation, oh, I'll do that now. It's really about a way of thinking about the approach here. It's a new, completely, you know, it's like an extra responsibility you've got to consider taking with your designer. You've got to talk with the other designers and the other planners about this. But, you know, you can't just throw any system in.
Well, there's lots and lots and lots of stuff in this 422, and to be honest with you, we could do a whole webinar on it, but I'm not going to. Yeah. But some of the guidance effectively says keep cables as short as possible. CMS, don't use plastic, which to me, as we said in our DPC, John, the death of plastic trunking. Resistance to flame propagating cabling, why not? Why wouldn't you? Mechanically protected, kept out of reach, and read Appendix 13. And that's kind of really all I'm going to cover.
It's very much the same kind of thinking as we used to, or we still always have for locations with stored combustible materials, where we'd say only go in if you have to, don't go in if you don't need to, don't have any joints, have the systems be non-flame propagating, you know, these kind of decisions to make, you know, don't do any unnecessary stuff in there. And it's just kind of expanding on that now for these protected escape routes.
So Darren Sloan has said fire alarm panel supply is wired in FP200. I don't, I wire it in FP600. That's me, because I've made a choice to use FP600 mainly, in fairness, because FP400 you have to buy 5,000 meters of the damn stuff. That's why I went with it. But it's a 2-hour fire survival cable, so that's what I use. And also my UPSs are rated for 2 hours, not 1 hour. So that's why I make that engineering call. Moving on, surge protection. It was chaos. There's some various devices that we've all seen. Some new to the market, some old. Some on the value range, some on the expensive range, but there's the plethora of them. And we had this carnage of a regulation that caused a lot of arguments, and we had the calculated risk level, and nobody could understand, and everybody wanted to get out of it. And to be honest with you, it was frankly an embarrassing set of behaviours from the industry because of a poorly worded reg. Let's fast forward to the new Big Brown Book, and there we go. Far simpler. The risk assessment is gone. Very simply, protection against overvoltage shall be provided where the consequence caused could result in serious injury to or loss of life, failure of the safety service, fire alarm, smoke alarm, emergency lighting. They're all safety services. Significant financial or data loss. So this computer here sat in front of me is a couple of grand. SPD protecting it's 29. I know it's a hard sell, but I would just cruise control default this, and this is what I've been saying for a while. For all other cases, protection against transient overvoltage shall be provided. So if it's not in M3, you're still providing it, unless the owner says no. Okay, that's going to be an interesting document to write. So I think this is far easier.
That thing with the owner stating it, basically, I'd steer well away from doing that, particularly on domestic. Because the problem is, even if you get Mrs. Jones in her house to sign something like that, the reality is she's not going to understand what it means. She's not going to be, it's not going to stand up in any kind of situation where a TV blows up because she didn't have a surge protection fitted. So unless the person actually signing it does actually have a decent knowledge of what they're actually signing away, don't go there, because in any domestic situation, the owner is not, they're highly likely not going to understand what they're actually signing. So just stick the surge protection in. If you're even a cheap one, just put it in. It's 25 quid or something. I mean, really.
Remember, over voltage protection is one of the fundamental principles. So you're doing there, is you're negotiating with a ordinary person about how to help you not comply with the fundamental principles. Technically, I don't get it.
Yeah, I don't get it either, and I think that's probably a dangerous thing to even go down. But
Yeah, so
don't give
stick it in.
Right, John, do you want to cover identification
Yep.
analysis?
Right, 514. Yeah, this is your labels and your labeling of conductors and that. So we've now got 51413 was except where there's no possibility of confusion, unambiguous marking shall be provided at the interface between conductors identified in accordance with BS 7671 and the conductors identified to previous versions of BS 7671. So this is where you had your old colours, red, yellow, and blue, and now we've got new colours, which aren't new anymore because they've been out for far too long.
This is basically the regs just saying to us we're old now, isn't it? Really?
Yes. So basically, mark the cables where they are joining together. It doesn't actually say mark them with colour, so you could have numbers or letters, as long as there's some kind of marking on it. That's kind of the point there.
Indeed. Right, moving on. Now, everybody knows table 51, which is the colours. I don't know why they keep bloody changing this, but it seems like every edition it keeps getting changed. Again, more harmonisation. It may change again on the 19th edition, Dave. You never know.
You never know. No.
Hoping that standard is a huge typo. But yeah, so 51 functional earthing was cream and is now pink. So available from an RS catalogue near you. If you do any functional earthing, I've only ever seen it once, and that was in a mistake made by a designer on his interpretation. And that was cream. That was like a 95 ml cream that somebody went and got a load of heat shrink and changed it to green and yellow. Yeah. Back on the identification and notices, John.
Yeah, this is all your labels, which if you've put consumer units in the recent times, there's a great slab of labels which are supposedly slapped all over them, making a right mess. So here they all are. There's a whole list of them there. Warning of voltage, live parts, periodic inspection and testing, testing of RCDs, periodic user testing of AFDs, which is only in 11.2 of the actual schedule there.
Yes, it's not a requirement. I think this is an error. So for those who are looking for mistakes, the requirement for the AFDD label only appears in the inspection schedule. It appears nowhere else, but it's stated it's a requirement in guidance note 3. So it's an error in guidance note 3, and it's technically not a requirement unless you take an informative inspection schedule, which isn't a normative requirement. So it's wrong. Anyway, carry on. Sorry.
Anyway, yeah. So earthing and bonding, alternative supplies, surge protection devices, high protective conductor currents, and the presence of diagrams, instructions, similar information. So all of those things which you're fairly familiar with. And then in domestic and household premises, periodic inspection label, RCD test label, AFDD label, SBD label are not required. So all those labels, you don't need them anymore.
Well, it gets onto a bigger issue.
Yeah, it's the aesthetics. I mean, a few manufacturers, I'll name Schneider, for example. They've got their domestic board. You can buy covers for it, so it matches your wallpaper and stuff.
Yeah, and that's, I think, where it's going. The
aesthetics in the home, it matches the smart home kind of ideology, and they don't want labels all over it.
Yep.
Yeah. So
it's gonna look sexy.
The upshot of all this is a bit in yellow. So the requirements of this regulation need not be applied for domestic or house premises or similar installations where certification for initial verification, complete with guidance recipients as detailed in Appendix 6, has been issued to the person. So in other words, if you've given somebody an appropriate certificate for the installation, which, let's face it, should be happening anyway, you don't actually need to put all of those labels slapped all over the consumer unit and on the front and the back and the side and stuck on the wall next to it, which should make it considerably tidier. Whether this is a good idea, it's another story.
I was going to say, if you go on the E5 Instagram, you'll see this beautiful board with labeling that I did that some people say is a bit much, but it was compliant. I get the point that we have too many labels. I would rather see just one sign or label or something that is affixed to the inside of the lid that covers all the information needed, or on the wall, because you're right, fuse boards have got to be sexy, and this regulation is so confusing because it starts off with a diagram chart table with all the wiring, i.e. a full commercial industrial design. And then as it goes down to the domestic home, it pretty much says, just issue a certificate.
See, I love the idea of having labels off, have it all look pretty, and having all the data and all the information in a manual, in like a here's how to use your electrical installation. But I know that a lot of homeowners are just going to throw that in the bin. So it's like,
So this to me says don't bother labeling a domestic as long as you issue a certificate.
Yeah, which is okay if they keep the documents. But as anyone who's done domestic will already know, 99.9% or more of domestic installations have no documentation, because as soon as you give them to the homeowner, it goes in a drawer, a cupboard, it goes in the bin, and it's never seen again.
So there's been a very good point. QR code under the lid linking to installation information. I believe Mr. Certon, our friend at Certon, does that. So that technology exists.
One label.
So one QR code, and there is a rousing endorsement that Certon is 18th edition Amendment 2 compliant. There you go.
He just needs to. I don't know if he's got all the labels on. He needs to put them on there, and he'll
you
be
need
fully.
To stick them on there.
Yeah. Put them on there if you're watching. Then you'll
stick
be
them
fully,
on if you're watching.
You'll be fully fledged.
Indeed. Right. Again, just a little bit here on all this needs to be harmonised with relevant standards now. So again, more global harmonisation.
Yeah, they all have to comply with those particular standards, which, if you wish to go and buy them, are surprisingly expensive. And the main change here is the colour of the labels is now actually defined because it comes from those standards, whereas previously you've probably seen all the labels with different colours and designs and sizes of text and all of that. So at last, they do actually cover the specifics that are needed if you're going to use those labels. But of course, as we just saw, you might not need to use them at all. So nice bit of confusion there.
Yeah. Ryan Hopkins has raised his hand, although I don't think, Ryan, you can raise your hand in these, but good try. Right, so one of the other things that's been deleted, so if we go back to what you just said, John, about the interface between new and old, this regulation 51414 in the blue book was the dual color label, and it has now been deleted. So bye-bye.
Yep.
Cool.
So
doesn't that just contradict?
Yeah. So you need to mark all the conductors at every interface between the different ones, and you don't need a warning label anymore.
Yeah. Okay, moving on. Again, guys and girls, Appendix 11. It's a brand new introduced. I'm not going to go into them all, but there is a brand new appendix that gives you very, very clear information after the debacle of the wrong size labels in the 18th edition, I think it was. So yeah, there's a new appendix. It covers all the labeling you could ever shake a stick at. And so yeah, please go and check that out.
Yeah, the main point on that is that the text size is defined, and the text has to be black, and the background has to be white or yellow. So if you've got any labels that aren't white or yellow, well, they need to be changed, like mine, which are red. But anyway, more expense.
John, come on.
Terrible, isn't
it? What you like. Right, should we get into the really controversial one? The one that we've been saying for years and been getting loads of abuse over.
Yeah,
stop using split load RCD boards. So, Chapter 53, types of RCD, 53132. Everything in that is the exact same except for the section in yellow, which says the use of RCBOs for individual final circuits in domestic installations. With that rollout and the 30% maximum leakage current, they have been able to delete or retire certain clauses. So basically, if you want to comply with Section 2, use RCBOs. It's very simple. Stop using split load boards. They're a bloody nuisance. They've had their time. They're just rubbish, basically. To quote John, just put them in the bin.
Yeah, they were fine once, but that's before we had vast amounts of electronics in every building, which has leakage by default. So yeah. RCBOs is the way to go.
It is. And for those who are learning or have never worked with this, or this is a whole new world, just to remind everybody, there are different types of MCB. There are also different types of RCD. We will do a webinar on RCDs. That will hopefully be our next one, or the one after the next one. AC, type AC is still in the regulations, but we'll cover that in a second. Type A, which is really the minimum one you want to be looking at, that offers up to 6 milliamps of immunity protection from DC leakage. Type F offers up to 10 milliamps, and it gives obviously a multitude of frequency protection, because obviously a lot of this stuff has frequency converters in it now. And type B, which the standard really needs to be rewritten, and it is because it's in draft actually, is also 10 milliamp, but it gives you all variants of DC, whether it be battery or switch mode power supply or pulsed or whatever type of chopped waveform you encounter. So my personal opinion is everything should be type B, but it's prohibitively expensive and the technology isn't miniaturized enough. So type A RCBOs with a type F maybe for your kitchen is my recommendation. Now AC RCDs are banned, and they did discuss this at the IET. We said this, Dave, how many years ago?
2 years ago, mate.
3 or 4 years ago.
Yeah.
They are banned in Austria, Belgium, Denmark, Germany, and Switzerland. Mainly probably because those countries have got the guts to actually ban them. We should have banned them. Type A RCBOs, by the way, have been out for over 20 years. We got catalogs going back to the 90s with this stuff in, so type A is not new. Carrying on with that, regulation 53133, RCD type AC shall only be used to serve fixed equipment where it is known that the load current contains no DC. So if you go to your granddad's shed and he's got one of them old bar heaters, AC RCD all the way. Anything else, even this new Lot 20 heaters with their little electronic digital programmers, forget about it. So by default, you can now see the official clear journey that AC RCDs will just be phased out.
Because suppliers will just stop bothering buying them in.
Yeah, and they'll disappear naturally. And if you look, I've put Verso on the screen there because they've got a really good hashtag, and I'm not sponsored by them. They've got a good hashtag. I think it's Ditch AC or Type A only or something. They've got this marketing thing where they do not produce AC at all, which is a great stance from a manufacturer. So hats off to them. It then gives you a couple of notes, which gives you examples of fixed equipment in case people want to row about it, because electricians do love a good row over silly things. Note 2 is an interesting one for guidance on the correct use of RCDs for household and similar use. See published document IEC Technical Report 62350, which is a little bit old and needs an update. And also note 3, some typical fault currents in circuits compromised in semiconductors, which is that big chart with all the little wavy lines and stuff like that. So if I then show you as a Brucey bonus to this, PD IEC Technical Reports, you don't have to buy it, it's here. This is all the relevant bits that electricians need to know. Really simple. It's about leakage of connected appliances. So leakage from a circuit can be worked out via the sum of connected appliances, i.e., let's say there's 10 PCs, and we use the worst case of leakage current. Let's say it's 2 milliamps. So it's effectively 10 times 2, 20 times 0.75. That's your design leakage of the installation. And you have to make sure that your leakage meets within the 30% rule. Henceforth, an RCBO helps with that, because if you've got lots of circuits and lots of leakage, it will trip out one RCD. You have lots of RCBOs, you comply. And yeah, so that's basically that standard. It's a lot of money for basically that.
The a couple of things in the comments there. Paul Bruton and Nicholas Priest, C3 for a type AC RCD, and the answer is definitely, depending on what it's supplying. But if it's supplying just socket outlets, definitely, because you've got no control over what can be plugged in, and anything that plugs in pretty much is going to have some kind of electronics in it with DC in there, unless it's going to be like ye olde electric fire with the glowing element in the front. But pretty much anything else, yeah. So definitely a minimum of a C3 for that.
So I'm going to go C2.
Yeah,
so that will that will move to C2 soon.
I'm going C2. I'm going C2 because we've known about this shit for, excuse my language, we've known about this for decades, and we've ignored it and tried to brush it under the carpet. But if you walk into a house and you've got the Xbox, the PlayStation, the 50-inch TV and everything else, don't you dare sit there and go, yeah, that AC RCD is a C3. It's not, because one bit of fault current from that and boom.
I said this to the lads. I said this to the lads in Discord one night about doing EICRs retrospectively and stuff. I said, fundamentally, we're going to look at the installation today and look at how it's going to be used, the utilization of the system as in its condition now moving forward. And if you have a number of items that are going to potentially blind that RCD, then you cannot have confidence that additional protection is achieved anymore. And in those circumstances, you may as well assess that there's just no RCD there for the purpose of additional protection.
Another point just to make there, if you're not aware of this, if you're putting in different types of AC, say you're going to a type A or a type F, whatever, you're not losing anything at the bottom. A type A also covers all the stuff that type AC did, and a type F also covers a type A, and so on. So by putting in these new types, you're not getting rid of anything, you're just adding additional levels of protection on there. So it's not a sort of losing anything, it's just putting extra stuff in. So
I think Andrew Brown has nailed it. C2 from now on, not before. However, militant me has always C2'd it, because again, there is this general consensus of behaviors as to what's acceptable within the industry.
Yeah.
I wrote an article in 2015
Yes, you
about
did.
AC RCDs.
I put up a YouTube video, I think 2019. I think I called it, "Should we just stop using ACRCDs?" You know, it's like,
absolutely.
you know.
So for me, it's always been a C2, but it's coming. We need to, I don't know why in this industry, we need a general consensus to feel accepted that it's a C2 or C3.
The funny thing is, let me go on my soapbox right now. They'll then go, "Oh, we have to harmonize with Europe. That's why it takes so long." When Europe's 10 years ahead of us with this.
at least.
Yeah, no, so
Well, in terms of the banning of them, I mean, Germany got rid of type AC in the 1980s. So yeah,
that doesn't
not
work
a recent
here.
thing at all.
Yeah,
So,
and that's the sad thing. We are so far behind Europe and the technological developments. Oh, one other thing, by the way, before we move on, apologies. If anybody wants to understand leakage of devices, and that list is very small. Now, that standard was written in 2006. If you go online and look for Schneider's RCD protection guide, it has an entire table where they've basically made that about 10 times bigger for like cookers and all sorts. And it gives you the leakage there. So they've done a great piece of work. It's free.
It's also got a great information about RCDs. Obviously.
Yep. It's free. Right, we'll move on. John?
Yep, Chapter 54, Earthing and Protective Conductors. 54372204. The requirement having dual earth terminals on the back of your accessories has been removed.
Indeed.
You don't need it anymore.
That's one of the retirements from this whole installation leakage. The enhanced coverage of RCBOs removes the need for this.
Yep. So all that thing about your having a ring of protective conductors with separate terminals and all that, gone away.
How many
as well.
How many electricians have fallen out over it? Oh, you haven't done both. You haven't independently. Oh, God, you know what? I'm glad this is gone. I do like the two terminals, and I hope they stay. But yeah, I just it's nice to know that it's not one of those you'll be witch hunted for. Just lastly, while we're on Chapter 5, I know this has got nothing to do with Amendment 2, but for those people in our industry have said you shouldn't code fire alarms. I call bullshit on that, because 56010 is very clearly fire alarm shall comply with 5839. You're not expected to know 5839, but if you see it hanging off the wall, you see to it. If you see something that's blatantly wrong with the cabling installation, you code it. Why? Because in 5839, as you can see from the circle, it requires all the installation practices and workmanship to comply with 7671. So if anyone from an industry body says, no, you don't code fire alarms, let them stand in a dock and explain that to a judge. Because I can't think of I can't actually understand the argument against it, other than
there's no argument against it. There's no argument against it other than their inability to support and develop competence amongst electricians.
Absolutely.
Yep.
So
I'd like to, before we move on from here, the very first question that came in this evening from David was in this area, so I wanted to hold on to it to now. His question was, would not having SPDs on emergency lighting circuits result in a C2 on an EICR? So an emergency lighting circuit, 5266 kind of coverage, no SPDs, fixed wiring.
Yes.
So we've got a crossover here.
The same thing can apply to domestics with smoke alarms.
Yes.
Because it's the same thing. It's a safety device. And if there's no surge protection, it could be destroyed.
That's why
and you wouldn't necessarily know.
That's why I have an SPD on my house, two of them. For redundancy, but no, yeah, I even if I go to work where I've got a UPS and a battery system, I have surge protection on the mains, transient low voltage protection on the mains, and on the DC side and on the output side, because I make sure I protect all of it from switching surges. Do you know the reason why this is an argument? It's because we're not used to doing it.
Is it?
We're not used to doing it because it drives up cost, and rightfully so. our industry has got a grey economy of people who are cutting the corners, who don't know, who are undermining all the good guys.
Yeah, and all those good guys. Again, I met with an electrician a couple of weekends who gave me some electric vehicle charging points for my training company because he's given up the tools because he can't compete. The grey economy, we have to find ways to try to shrink that because the good guys are just giving up.
Yeah, they are. And it's not just retirement from the regs. During COVID, we've lost a lot of good electricians out of this industry, a hell of a lot. You know, people have retired and walked away. Part 6, drum roll, everybody's favorite bit, inspection and testing. There's no new test equipment that you'll be pleased to know.
No, however, but there is a question if our test equipment isn't used anymore.
Yeah, tell me about it. So this is a controversial one. There are some changes. Basically, in summary, IR, RCD testing, schedule of items inspected and schedule the test results. We'll go into it now. But before we do, there's a couple of minor things. The initial verification checklist has added the earth electrode requirement earlier on, and also it has a weird note in 643731 about doing tests and test instruments being affected by inverters. Now, I don't know if this is an EMC issue, a compatibility issue, an earth loop issue, because when I used to do testing, going back 20 years, when I used to do testing on inverters, we would do, let's say we do Dagenham station. Dagenham had a UPS system, an inverter, and we would do the earth loops with it on bypass. We would switch the inverter in and we would do the test again to ensure that that disconnection time was still achieved through the inverter.
Yeah.
But now it's saying don't do that. And I'll be honest with you, I'll happily blow an inverter up every day of the week if necessary. And you can laugh at me on YouTube world, but that's how I was taught. And I can't see the counter argument other than, well, the electronics are sensitive. We'll go out and buy a better inverter. So this is either a compatibility issue or it's we might damage it. If it's a might damage it, I'd be going to the manufacturer and saying, well, it should be able to take this. John, IR.
Yep. Insulation resistance. This is what the Blue Book used to say. So measuring it between live conductors and between live conductors and the protective conductor while it's connected to the earthing arrangement, and where appropriate, line and neutral conductors may be connected together. So that's what we had. And now in the new Brown Book, insulation resistance shall be measured between live conductors and the protective conductor connected to the earthing arrangement. During this measurement, line and neutral conductors may be connected together.
Pretty much the same thing reformatted.
Yeah,
it is. So, but I just had, I was listening to a webinar. I can't remember which I've watched so many. I can't remember who it was. One of the IET guys, I think it was, said the rewording has been done with an intent to make us do the live to live before we connect equipment.
Yeah,
doesn't say that, but
that's
apparently is the intentioning. A lot of people install equipment, then they do obviously and this is the thing that I've always said when I do testing training. You do during erection and on completion, but a lot of people leave it till the very end, and they don't disconnect the equipment anymore because of dismantling. So they've done this in an intent where we do the live tests between equipment. Before equipment's connected, and then we can do live to earth after. That's kind of what was said, but that's not worded here this way. But that's what the IT, I think it was the IT said.
Yeah, and also to clear here, 64 is initial verification. So this is your new stuff you've just installed. This is not periodic or EICR. So this is where you literally.
I was taught that you always measure it before you connect all the bloody accessories anyway, but it's fairly evident from these regulations that people are installing it, lashing it all together, second fixing it, then doing the IR test.
You got a team of guys doing the cable pulling, you got a team of guys doing the second fix, then there's another guy who actually may be the one who's verified by the CPS coming at the very end doing the initial verification.
Just remember, guys and girls, when you are doing it, remove the surge protection device. You don't want to be blasting that thing.
Yep. And if you do try and test it on with it there, it will just give you a 0 result anyway. So you'll know pretty much straight away that something is not right. This is table 64. That's your minimum values. So for any normal installation, it's 500 volts and it's that 1 megohm minimum resistance, not 250 as the main one. You can use that in some cases, but you need to test it at 500 unless it's one of the others in the table there.
So let's just move on a bit here. Where the circuit includes electronic devices which are likely to influence results, and this is the excuse now for not doing it properly. Only a measurement between live and conductors connected to an earth shall be made. It then says additional precautions such as disconnection may be necessary to avoid damage to electronic devices. Yeah, that's fair enough. So this to me is second fixing, going back and doing it. Fair enough. Verifying after you've put all the floorboards back and all the rest of it. However, where connected equipment is likely to influence the measurement or result of the test or be damaged, the test shall be applied prior to the connection of equipment in accordance with what we just saw, table 64. Following connection of the equipment, very important wording there, that's new. Following connection. So that infers, don't just lash everything in and connect it up and then test it. So they're trying to pull people back. It then says a test at 250 volt DC shall be applied, but you still have 1 meg, which goes against table 64, because table 64 says 0.5 at 250. But this is again on new installations. This is worded to stop people throwing shit in, connecting it all up, and then just blasting it across all the cores. That's all. So I see this as a good thing. It's probably not what we want in a purist world, but it's a good thing. Then there's a little note that says manufacturer instructions may recommend some equipment to be disconnected during 250 volt DC installation tests, as it may influence the results of the test. How many electricians are looking at, when we do the earth electrode testing on my route, we analyze the test results. We analyze so we can understand the performance of the soil when we do that on a Saturday. And again, perfect example, SPD, pointless, take them out because it will affect the test. John.
Yes.
Favorite table.
RCD testing. This was what was in the blue book, which was table 3A, which is all the details for the most common types of RCDs and how long they should take to trip and all of that. Moves in appendix 3, but it's gone away. It's been deleted. So all that information has now disappeared, at least from the BS 1. And there's some deleting wrestling person.
That's Matt Hardy doing his broken Matt Hardy gimmick. I'm a wrestling fan. Sorry, everybody. But he is the deleter of worlds. So I just wanted to put that in because it's my presentation. Moving on. Apologies, John.
Yeah. So in conjunction with that being deleted, 6438 additional protection, the testing of RCDs. Now the yellow bit is the bit that's changed. So regardless of RCD type, effectiveness is deemed to have been verified when RCD disconnects within the time stated below with an alternating current test at rated residual operating current. For general on-delay types, it's 300 milliseconds. So this is basically saying, don't bother with a half, and don't bother with the 5 times, don't bother with all that other stuff, and don't bother with the type A and all the rest of it in the testing devices you've got. Just test it at AC at the rated current, and if it trips within 300, all is well, supposedly.
All is well.
This is not really very satisfactory, is it?
It's not, and I believe the IET, one of the comments from the gentleman there, and it was a great presentation, but I think the phrase he used was, so less testing, which is a good thing. No, it's not, in my opinion. It's not a good thing. Given the skills gap and the competency issues we have and the quality of installs, no, it's not. So I'm going to happily make a statement here. They did mention that half-time, 5 times test, the RCD type, the ramp test and the phase angle 0 on 180 degrees, although it's not in the regs, can be used for fault finding and other bits. My advice is do not stop doing the full testing, because I don't want to be stood, or anyone to be stood in front of a judge where you weren't able to show that you fully interrogated the testing. Now, if I can be controversial here, we will cover this in an RCD webinar, but we have written to every single manufacturer of RCDs in the UK, and we've got multiple different answers. So the first port of call is seek advice from the manufacturer on the requirements. What they call, is it Proteus? Not Proteus.
Dobka?
No, not Fusebox. Who's the other value brand?
So many of them now.
There's so many of them. Luden. Thank you, Andrew Brown, in the comments. So Luden did a 2-page guide to testing, and it's still required type testing on AC and A. So this is a minimum, and this is where we need to stop panicking and go, the regs are a minimum guidance note. I feel sorry for anyone that does a 1 times test at the RCD, because all you're doing is mimicking effectively part of the factory performance test. Now, I've noted over the years that I think it was the NIC who said just test at the terminals because of the capacitive effect of the circuit. Wrong. When I was, and I know, Dave, there is an argument to be had that we should trust RCDs like we do MCBs. Wrong, because MCBs don't get blinded like RCDs. So that's my personal professional opinion. The other thing I would really like to get on my soapbox about, and it is a soapbox, is if we start cutting testing down to a minimum and we test at the terminals, then there is no point to it. Yep. When you have, I was taught testing that when I go out, I interrogate connection of the protective conductor at each point. Why? For safety of the fixed or portable equipment. I'm then also testing earth loop at each point. Why? To ensure the protective device will disconnect. I then test the RCD at the end of line or each point in the circuit. Why? To ensure the device works at every point in the circuit. That has disappeared now to just test at the RCD, which is wrong, because if I test at the end of the line of a radial, let's say in my living room downstairs,
yep,
and I have a capacitive effect because of printed circuit boards in parallel and various other bits, then should I be even selecting an RCD? Or can I actually rely on the RCD's performance? Probably not. And we will go into that in more detail on our RCD webinar, which I've been writing for 4 years now.
We have been working on this RCD webinar a long time.
4 years. It's nearly ready.
It's nearly ready.
Nearly there.
But we now need to tie in this.
And worst case scenario, always.
This nonsense.
Test at terminals without load connected, fine. But do it again with load connected. Remember something. RCD testing, you are verifying the performance of your installation with connected load. Sometimes you can't do that. But
this is the problem. If this is, I think, what the problem is, Paul. I think if you're going to test an RC, if you say to yourself, I am doing the manufacturer's product testing and confirming the 1 times I delta N,
yeah,
then fine. If you say, I've selected this device for the perspective for the requirement of additional protection with regards to the utilization I've observed and the equipment that's been selected, and then you select an A type and all this stuff, then you go to the device and go, I delta N AC, you're not going to verify any of that safety that you've really selected for.
So how about this then? In the next edition, why don't they change it to you test at the terminals at the end of line when you're doing initial verification, but on an EICR you have to test end of line to verify the performance, the safety performance is not been impeded by the connected loads.
But then you've got the connected loads, and then you've got the issue of equipment damage and all this other stuff. And what manufacturers don't want
damage. What equipment damage? It's a low current test.
You've seen what they've said.
No, but that's like me just saying, please don't switch off my UPS because I'm scared it won't work because I haven't maintained it. Every single product under the supply of electrical equipment regulations should be able to take a number of switch out and reinstate, repower up without failure. If people are worried about damage because they're not looking after their stuff, tough. I always look at that as an opportunity to go, great, something's failed. Well, it was going to fail or burn out anyway.
This is what I'm looking for Sean in the chat going about his Virgin box or his Sky box.
Is Sean in the chat?
Apologies. I don't think he is. I've not seen him actually. So.
Okay,
yeah, the thing with those failing is that if you've got stuff, particularly like skyboxes and things which are turned on 24 hours a day, 7 days a week, what often happens is that the capacitors inside, the electrolytic capacitors, they get warm and they dry out and they don't work anymore. They're enough to keep the box working, but when you switch it off, it doesn't have the correct values to actually get the power supply started. And it's like, oh, you turned off my skybox and now it's broken, so you owe me a new one.
That's the problem.
It's broken anyway.
The equipment's been on for months. So now it's discharged to capacitance and then it recharges, it kills it.
So what you're telling me is it never should have been sold under the supply equipment regulations.
Yeah, it's cheap junk basically.
Yes, and this
like
is
a lot of electronics are.
This is what happened when AFDs came out in Europe, in Germany. We were told that thousands of them were returned because they were tripping out because of crap white goods. Now, in the Irish regulations, just here, there are actually clauses that talk about knowing the connected loads. Now, I think it's inevitable that we're going to have to start asking more and more questions about what's being plugged in.
But I think one of the reasons we're doing the 1I delta N only now is because device manufacturers don't want them returned for obviously false failures or stuff like that. I think that's probably one of the reasons.
Yeah. Right. Let's move on.
Let's move on because we can talk about for hours.
Yeah. Model forms. So the electrical installation certificate, there is a change. The big blue arrow should be brown. Sorry. Schedule of inspections. It's been simplified. On the form, there is still necessary guidance within, but this is just a simplified tick box as an oversight. Personally, I'd have just left the old schedule tick box in. I don't know why they've gone to this, to be honest with you.
Bear in mind, these are the model forms, which basically nobody uses anyway, because obviously you're going to use your software, whatever, anyhow, which in many cases has different things in anyway. So
don't stop using your software in accordance with John Ward. There's a schedule of inspections there. Condition of consumer's intake. It says visual inspection only. As we've argued before, why do ZE then? That's the obvious question. Basic protection, various other prosumers in there. So that's the new schedule of inspections. One of the good things that the IT have listened is the old, really compact form has now been split into two. So generic schedule of circuit details. They've got an inclusion for SPD type. They've got a place for your company logo. And they've also got on the RCD column an ability for you to put what type of RCD. So that's just the circuit descriptor and the circuit information and protective devices. There's then obviously a schedule of test results now where they've just, as John said earlier on, they've just looked at what other people are doing and spread it out. And there's now at the top, they acknowledge multifunction testers because that's what a lot of people use now. And that's pretty much it from a electrical installation certificate and schedule. There is then the model form for minor works. Minor works form is just, there's more guidance at the end of all these forms, by the way, that's been updated. But I love the minor works certificate because it's really simple. Description, what you've done, presence and adequacy of earthing and bonding, the circuit you're working on, details. They've added RCD, AFDD and SPD in there, which is great. They've also asked for your installation resistance test voltage. It's that important now. They want you to declare the test voltage. So if you don't declare 500 volts, you corner cutter you. It's very important. Moving on, EICR form, pretty much no real change there. However, on the condition report for domestic, in the schedule of items inspected, so this is the bit behind the schedule of items inspected, there is under intake equipment, the requirement still to inspect the service cable, service head, earthing arrangement, meter tails, metering equipment, and isolator. There is a note 1 that says, where inadequacies in intake are encountered, which may result in dangerous or potentially dangerous situation, the person ordering the work and or duty holder must be informed. It is strongly recommended the person ordering the work informs the appropriate authority. Note 2, for this section only, where inadequacies are found, an X shall be put against the appropriate item. And a comment made in section K. So this is interesting. So this is a new code. In my professional opinion, this is a new code. And what this is telling us is basically tell the duty holder, but don't fail the installation. So let's go into codes. C1, danger present. C2, potentially dangerous. C3, improvement recommended. FI, we know FI. C1, C2 fails. X code. Inadequacies found on DNO equipment. It is strongly recommended that a portion of the work is to report to the DNO. So this is now not been spoken about today at all, or the last 2 days. Very, very controversial. If we find an intake, yes, if there's live parts accessible, I'm assuming that we would still C1, C2 that. However, this is basically telling us if you're finding a DNO where the lead wrap or it's melting pitch, as we saw earlier on, or it's a poor earthing configuration, it's not your problem. Put it down as an X and still pass it. So this is something that needs more detail and depth. I'm going to Alex to ask the NAPIT boys what their view is tomorrow, but I would ignore this. I'm going to ignore it. In my professional opinion, when I'm writing my employer's specs, the X code does not exist. If I see DNO stuff that's wrong, I'm reporting it to 105. Now, I have a really bad feeling that the reason this is in here is because over recent years, more and more electricians are finding aged and prematurely failing equipment, including diverted neutrals. And this is a way of saying, well, it's not your problem. Potentially, it's just my opinion. But speed dial your DNO, X code. Don't put it in. Just do. That's my professional opinion.
Yeah, the problem with that, in particular on domestic, is if you say to the homeowner, "Oh, this whatever it is defective or broken," one, they're not going to understand what you're talking about. B, they're not going to want to call up the DNO or do anything else. So it's just going to get left. So put X down if you want, but for goodness sake, report it yourself. Just takes a moment, doesn't it? So
Before you move into this one, Paul, there's a bit of a chat going on about the CPS advising the calculation of ZSs on light circuits. So ZS is equal to ZE plus R plus R2 kind of thing. The electricity work regulation 14 scenario. Some people have been saying that their opinions. My pennyworth of this is, for you to obtain the value of ZS or full loop impedance, you have to actually have impedance in your value. A resistance and an impedance does not equal that impedance. So you have to actually have the reactance in your circuit. So you have to have the freaking thing energized. Remember that when we went to college, we did 1/2 pi FL and 1/2 pi FC, and we did what was it? Z squared is equal to square root of R1 of R squared plus XL squared.
I think what you're saying is
that we have to incorporate impedances, because that increases the reactance, because that increases ohms, increases the impedance.
Yeah, I think what you're trying to say is basically resistance and impedance are very difficult to mathematically equate into.
But they don't add up because they're at different. They go they go in that direction.
Yeah.
So how can I add them together? Yeah.
I mean, in the past, if you just had resistive loads, in theory they might be the same. But as we've already seen, no loads are purely resistive anymore. They're full of electronics and all kinds of weird capacitive and inductive loads and all that stuff. So you definitely cannot take one and then just calculate the others back from it. It doesn't work.
So,
and as for the thing about not working live, well, that's fine, but it only applies where there's no other option other than to work live. And if you're going to be testing ZE or ZS, well, of course you've got to work live. That's the whole point of it. So that's nonsense.
That's why you went to college, why you bought testers and
why you're a trained
PP and stuff.
Exactly.
Right, moving on. So this is just a little bolt on to that X code, and it's diverted neutral current, because I'm really pleased to say that in guidance note 3, diverted neutral current appears. So all the times we've been called names and called scaremongers and everything else, it does exist. It's like dry land. It's not a myth, although it is in a film. So GN3 section 3.3.3 and appendix D covers some guidance. There is a mistake in guidance note 3. It calls it appendix E, which is wrong. So I've already found a couple of errors and I'm on day 2. It basically covers safety checks, which are really important, which is why we did our podcast. And I'm not going to bore you with this. You've seen this in our podcast, but basically this is a C&E network or a PEN network, TNCS supply. If you get a broken neutral, it can basically be like this. And I can't read the words at the top. But basically this configuration is normal. This is where you export. So for instance, broken pen, you go from 3 into 2. So you're exporting your neutral current. And importing. I can't read the words at the top because of the way this script is at the top.
That's the export one.
That's the export one, right? Yeah, I'm getting them wrong way around. Apologies. So that's when you export. When your supply neutral is broken, you export to water and gas. That's when you import, because it's going out and in. But that's just kind of in line with guidance note 3 now on how they define it. One of the interesting things is somebody rung me the other day on this and said that they had a broken, what they thought was diverted neutral. And one of the easy quick wins to figuring this out as to what it's from is, rather than disconnecting the earthing conductor, if you've got a 4-way block, just disconnect all the bonds, reattach them, have your clamp on your earthing conductor and just see where your current's coming from. And then you'll know whether it's coming from your gas or your water or whatever, or through to your gas or water, because obviously they'll have different impedances. So just be wary, folks, that, diverted neutral current is a thing. It does exist. Nearly 20 amps of it on that picture there. Moving on to part 7. Mr. Watts, do you want to cover part 7 very briefly? We're not going to touch on this much at all because there's tons in it. But he's on mute, which is
sorry. I was gathering some some of these little clever thingies that I've been using for my diverted neutral current project for the 2391.
Go for it.
Anyway, right. This one has to repeat itself. So this is 71.414.3, which just identifies that when we have the methods of self and pelv as a protective function, one of the methods of achieving self or pelv was 414.3, and that uses electronics, basically. And there's a quote of it there. Certain devices comply with the appropriate standard where provisions are taken such that in the event of a case of an internal fault, the voltage on the outgoing terminals cannot exceed the value specified in 414.1.1, which is obviously self or pelv. High voltages at those outgoing terminals can be permitted in such cases, though. And I expect what they're going to say, and in cases where you have wet things, that's not a good idea. So without doing any more real investigation as to what kind of exact items this is, an example in that regulation is installation test equipment monitoring devices. Combine device that achieves protection that way where it can have a potential higher voltage on the outputs. Add that to a wet environment. I think the regulations go, that's not a good idea. So you'll see that in 701, you'll see it. Did you include all the slides for that in the others as well? All right, we'll see you again in a minute. What else have we got in 701? Oh, yeah, appliances have lost 0.5 meter of cable length, apparently. I don't know if that happened overnight, but the reason for this is apparently to do with just standardization according to the
European standardization.
Yeah.
Which I don't believe, because no other countries in Europe have that. But anyway, that's another story. So it's 2.5 meters instead of 3. Like, that's going to make any difference,
Mr. Ward. But yes, so 2.5 meters is the takeaway from bathrooms from 3 meters. There's a nice color picture of it.
One.
Moving on.
Right, the same regulation as before, but that one is swimming pools. Again, you can only use that. Here is for saunas, same thing. You just see the number changing. Conducting location with restricted movement, because a lot of our equipment now may use functional earthing in some form. If we're going to have a conductive location with restricted movement, we may have to have supplementary bonding to equalize any potential voltages if we're going to have currents flowing in earths. Because, the idea here is to have literally no earths or little to no current, or have hand tools or battery powered tools. If we're going to have equipment connected in and it's going to have functional earthing, there's going to be currents in the earthing. Therefore, it says we want to have supplementary protective bonding just to get rid of any potentials that can create in a confined conductive location. I guess it makes sense.
This looks familiar.
That's the same one for medical locations, yes, for your requirements of self and PELV.
Certain amount of copy and paste.
There is a certain amount of copy and paste, yeah.
Yes.
Right, RCDs, what have we got here? Medical locations of group 1 and group 2. Without going into too much detail, that's where we're going to use applied parts for the treatment. And in group 1, the loss of power will not create a risk. In group 2, the loss of power will be a risk to the patient. In either of those, RCDs will be required. Only type A, B, or F are suitable. No AC RCDs are suitable.
Which is marvelous.
Marvelous.
Yep.
Photovoltaic.
I'll cover
PV.
this.
Go on in.
So PV, I've been saying this for years. So PV in 712 has been dramatically out of date.
Yeah.
The BSEN series of standards have been leap years ahead. There's lots and lots of technical stuff in there. It's quite a heavy amendment, pretty much a rewrite, to be honest with you. But in a nutshell, you need to make sure you've got isolation on your DC side and your AC side, and make sure you've got surge protection on both sides. That's kind of basically how I summed it up. It's what I've been doing on my solar systems. And I've actually had rows with my solar contractor who was like, no, I don't have to do that. The NIC have told me not. Well, if you read the BSEN standards, which you can apply, it's in there. They've just novated it into here. There's lots more in there, but that's kind of the takeaway summary of what I'm doing. And lots of technical stuff.
For us to cover the changes, this would add another hour to the webinar, and it's just a specialized area, really.
It is.
So that's a good summary of it, isn't it? Outdoor lighting installations, additional protection of RCDs to 415.1.1 for anything that is accessible to the public. There was that young lad, Harvey, I think it was, Terrell.
Yeah, the one in the pub.
The 7-year-old boy in the pub garden. He was electrocuted. These are things we need to think of. You would assume that, pub garden lighting would have an RCD, but, some people will obviously make these decisions.
Just on the outdoor lighting, it includes gardens, spaces open to the public, telephone kiosks, bus shelters, advertising panels, and town plans. But it doesn't include street lighting or traffic illumination of monuments or platform lighting at railways stations. So I've actually made a mistake there. Apologies. Railways are excluded, not included. Apologies. That's me being terrible. So we'll move on quickly and pretend I haven't made that mistake. It'll be fixed for Thursday.
The electric vehicle charging one. This is just a minor little addition, really, because of Just
John's.
This is John's.
Yeah, we'll cover this one. There's not a lot of changes here. This, has been added in. This really fits in with section, or part 8 rather, which is why it starts with 826, surprisingly enough. Essentially, where device complying with those standards is used to protect EV charging equipment, and a PEI, which is a prosumer's electrical installation, then the vehicle shall be electrically disconnected from the live conductor supply and from protective earth in accordance with that regulation. And this is in island mode. This is where you're going to be running your house from your battery storage and you're disconnected from the grid. We'll look at that in a moment. The disconnection of protective earth is pretty much going to happen with many of these supply points anyhow. So it doesn't actually change a whole lot. It's basically been put in there just to fit in with part 8, which we'll look at in a moment. There are a couple of other things which have changed there. We don't have a slide for this, I believe, but on the TN system, there used to be 5 things which you'd use as a protective measure in case of a open circuit C&E conductor. The first one of which was for a balanced 3-phase system, where you've got 3 phases and it's always going to be in perfect balance or near as. That has been deleted. And the reason it's been deleted is because it was completely impossible, because one, there are no balanced 3-phase systems. And even if there were, if you've got a 3-phase charging outlet and you plug a single-phase car in, well, boom, straight away, that's an unbalanced system. So that's gone away, but say no one used it anyway. So just a load of nonsense. And there is another minor change there, which basically fits in with the RCD things again. So you can't use type AC RCDs anymore, not that you should have been doing anyhow. So that's just been updated to fit in with the rest. So nothing really. Yeah. And there's a few other bits where they've changed the capital letter and a full stop and so on, but
not enough for a new bit.
Right, let's go rocket mode through part 8, John.
Now, this part 8, now, if you've seen one of our previous webinars, you would have seen most of this before, because basically it's part 8, which they've added in. All of this is completely new to BS 7671. Didn't exist previously, but it did exist in the standard that it's basically being taken from. So scope of this, it covers the local production and storage of energy. And this is for your prosumer installations, which is a producer and consumer of energy. So as we've got in the diagram there, you've got your generation locally, you've got storage coming in from the grid, going out to the grid, and this is where the word pro and sumer comes from. It's just those 2 words sort of stuck together like that. And that's the PEI, which we saw previously. Now, this diagram, which comes from UK Power Networks, which they have allowed us to use here, this kind of gives you an illustration of how complicated things are getting. And I say getting because they already are. It's not just a question of here's your transmission grid and there's a couple of generators. You've got all of these different things connecting into it, in most cases in both directions. And you've got your, say, solar, electric vehicles, battery storage, fleets of vehicles, taxis, wind farms, both large scale, small scale, solar farms, solar on your house, batteries, all of this stuff, all supposedly connecting together in a nice harmonious way and all working perfectly and properly 100% of the time, in theory.
Can I just say, John, that I really hope I'm retired when this becomes reality.
Yeah, well, unfortunately, some of this is already becoming reality.
This is insane. No, we wonder why it's getting harder. This is, thanks to UKPN, this is insanely difficult. Right, let's look at modes, John.
Right, modes. This is for your prosumer's electric installation. We've got island mode, which is where it's disconnected from the grid, but crucially, the installation remains energized. So this is where it's going to be powered from your local battery storage. And then connected modes are where you are connected to the grid, more the sort of traditional arrangement where grid power comes into your house and it obviously powers all of the stuff in your house. And there are 2 connected modes. You've got direct feeding mode, which is, in other words, the grid is supplying your installation with energy. That's your standard traditional type of thing. And then you've got reverse feeding mode, where your house is supplying the grid with energy, and then the energy companies are paying you to supply energy that way. So it's going in the opposite direction. So, and that's something that's fairly new. So you could charge up your batteries on cheap electricity overnight, and then those batteries could then be shoving power back into the grid in the daytime, when you can sell the same electricity back at twice the price you paid for it.
It's weird because you're paying out for energy and then they're paying you for energy. So it's like, give me your money, I'll take it back. Give me your money, I'll take it back.
It's all about that balance of filling the bathtub. If you could take energy when there's no other demand and basically store it for them, then when they need more demand, they'll take it back from you. Because the network can only carry so much. So it basically means you are making yourself little power stations for them.
Yep.
So types of PEI, so that's your prosumer's electric installation. an individual installation, which is fairly obviously it's an individual building. Got your grid connection there from the public network, which now is the distribution system operator. Inside your house, you've got your power supplies, loads, which is all the stuff there, and storage. So typically batteries, but could be other items. So that's the simplest form there. Next one up here is called a collective. And this is where you've still got your public supply coming in, but you actually have a multiple set of consumers. So say a row of houses or block of flats or something like that, loads in each one of those. And then you have power supplies and also battery storage or some other form of storage in a single unit, but that can then power one or more of the other items. And because it's a collective, obviously we just had to put that in there, didn't we? So why not?
We have
compulsory.
Jedi kittens, we're having Borg drones.
Yeah. And then the third type is a shared. This is similar to collective, where you've got your public network coming in, 3 properties in this illustration, but the difference here is that each individual property has its own supply, loads, and battery storage in there. So they are sharing the same network connection, and they can share things between themselves, but they can also operate individually on their own if needed, unlike the previous one where it was obviously just one set of storage for a set of people. And again, the storage is optional, so your neighbors might have batteries, you might not have. So there's all kinds of different combinations and variations on that. And we can see there that in that particular kind of arrangement, you could disconnect from the public network, and then you could run your house with your neighbors all together and not have any grid connection at all. So your house could supply your neighbor's house, and in theory, you could be charging your neighbor for that usage of electricity. Right, EMS, another abbreviation, it's in the definition. So it's the Electrical Energy Management System. And it's just one of those things that comes up there. This is basically supposedly a piece of equipment which manages your local energy production. It connects your installation to the smart grid for your smart meter and all of that, manages your local energy consumption and manages energy procurement. This, in theory, could be a single device, or it can be a collection of devices. Some of these are kind of on the sort of horizon now. If you buy those, some of those My Energy vehicle chargers, they can control, if you've got solar panels, they can use the panels to charge your vehicle or heat up your hot water, and you can also put battery storage in, so it can then sort of decide where the energy goes at the best time, and obviously making the best usage of that. There is an annex for that, and also a standard which you can buy, which is basically the standard where all of this actually came from.
Yeah, we should have allowed that to go into the 18th edition as energy efficiency, because in the last 18th edition, chapter 8 was going to be energy efficiency, and because we voted it out, it now is going to cost us 300-400 quid to buy the standard. It's part, it's in Appendix 17, but it should have all been harmonized.
Yeah, 60364 is basically where most of BS 7671 comes from. So -8 is part 8, and 1 would have been things in 8 starting with 1, but for some reason it's not in there. So we went straight to number 2. Now 826, this covers some technical issues with these things. So first one of which is protection against electric shock. A lot of this is similar to the other things there. One of the main differences is that the operating mode, whether you're in island mode on your own or connected to the grid, this can change at any time, and whatever protection you've got in there against electric shock must be effective in all of the modes. So to continue on that one, yes. So essentially, whatever you're going to install in terms of, say, circuit breakers or anything else, it has to work when it's connected to the grid, and also when it's running, say, from the battery storage, which can have a lot of rather important considerations.
If anyone's interested, the IET Code of Practice for Energy Storage shows a configuration design.
Yeah.
And it shows dual board, so completely parallel installations.
It's a bit like how we were today. If we were working with generators in parallel, we'd have to make sure that actually, you know, the sources and the characteristics were suitable for the individual sources. So when it just switches from one to the other, the circuits should still have the outcome of protection required.
Yeah, it's not just shoving a load of battery storage in a cupboard and plugging it in.
Exactly.
A lot more involved than that. Protection against electric shock. The earthing type may change. So if you're connected to the grid, it might be a TN system. If you're going to island mode, it might be a TT system. So just by disconnecting from the grid, you may be changing the type of earth you've got for your installation. In island mode, you do need an earth electrode disconnected from the public network completely, and you'll also need a neutral switching device to either connect or disconnect the neutral and earth connections.
Mm.
And earth fault current, as you hopefully should already know, it's going to be completely different in TN, TT, and IT systems, IT being isolated, not to do with computers. It's going to be different for each mode, and you may need 2 or more devices for fault protection. So if you were connected to the grid as a TN system, and then you change over to TT, again, the fault current there is going to be completely different. You may need to put additional things in. And most importantly, each source must be isolated, and that's talking about the grid, your battery storage, your solar, wind generation, all of this other stuff. Where is the origin of the installation? Because it could move depending on what you're powering your installation from.
Indeed.
Protection against overcurrent. You've got to consider your short circuit current at all points of the prosumer's electrical installation. So again, if it's from the grid, it's probably going to be quite high. If it's from battery storage, it could be completely different. There might not be enough to trip the relevant devices. The direction of the current can change, as can polarity. It could have a combination of things connected. You could have the grid on, and you could have your batteries on, and your solar coming in. So all of these different things, you're going to have current going in different directions. And also, where is the fault relative to the protective devices? Because if you've got power coming in from different directions, that protective device might not disconnect the actual source of where the current is coming from, as that may change depending on where your energy is being created or distributed. Now, outage to public network. So in other words, if the grid connection goes away or there's some problem with that, you've got 2 choices. You can go into island mode and keep running, or you can just disconnect the whole lot, which is generally what happens at the moment. You've also got to consider the requirements of any switching devices. Are they actually up to the job of disconnecting and reconnecting the various types of loads you've got, and whether it's in island mode or connected modes? Just because you've got something that's suitable for connecting to the grid does not mean automatically it's suitable for connecting via your battery storage or any other types of system.
Also, John, we discussed the other day as well, if you do have an installation where you have network neutral currents, you're switching currents on your earthing. So
yeah, absolutely.
And regularly switching potentially. So it's far more complex, but a lot of this is covered, believe it or not, in the IET code of practice for battery storage and all this. So it's an interesting read.
Transit over voltage. So in other words, it's surge protection again. You're going to be switching between different sources. You're going to be changing loads on and off all the time. So surge protection is required. There's no question about that whatsoever. And in terms of connecting to the public network, you need to comply with the supply requirements, such as the voltage and the frequency. So that comes down to more of equipment standards. Again, there is an annex in BS 671. And there's also a website, which is decode.org.uk, which covers quite a lot of that, and that's freely available. Energy storage. You need to consider the inrush current and other capabilities when switching between modes, because if you're taking something off load and putting something on, again, it's not just turning on, say, 20 amps of load. You could have a very high inrush current there when you're changing between the different modes. And flexibility of loads and generators. Are they actually designed to operate with load shedding? So you can have things like, if your load is too high to work with your, say, battery storage, it needs to, say, disconnect some of those items or reconnect them if possible. And once again, this is in the part which isn't included, which is 6036481, and that would have been in BS 7671 if they'd chosen to put it in there, but they didn't.
We should have. We made a mistake.
So they'll have to go and buy it separately. And electric vehicle charging. An electric vehicle is a load most of the time. However, it can also be a storage device because it's basically a big battery on wheels. It's not permanently connected because, of course, you're going to presumably take your car somewhere and actually use it. And it should be managed by the EMS or the Electric Energy Management System. And again, that fits in with the actual charging supply equipment. And again, that should all fit in with that. And that's where you can, say, charge from your solar panels, batteries in your house, and all of that. And the important thing about that is most of that already exists and people are using it without really realizing it. Selectivity, same concept as with anything else. If you're going to have more than one protective device, you want to make sure that the downstream device operates first, such as your 3-amp fuse there, and the upstream device does not. You don't want to be taking out whole chunks of installation because of a small fault. And again, think carefully about where the actual upstream and downstream are, because that can change depending on where your supply is coming from. So there's a nice pile of complexity. And this, it also fits in with a thing we've seen previously in part 6. Loop impedance testing instruments may not work properly with inverters. You should still test it on there, really, but the results you get may not be what you expect. Now, this is really going to be up to the test equipment manufacturers, because testing things that run off of inverters is going to be pretty much a common thing, because anyone's got battery storage in a house or a solar PV system, you've already got these inverters. They're already shoving power in, and yet you should be testing with these things there, but some test equipment may not work properly with that. Alternative methods, yes. Well, we've kind of covered this already with the calculation thing. In theory, yes, you can, but yeah, calculating it is not really an option in most cases. Simply because you don't have the available information.
Okay, thank you, Mr. Ward. Right, so that kind of gets us to the end of it. Apologies, it's been a long haul. Just to let everyone, one, to thank you before we get onto the questions. Two, there's some good industry guidance that is out there. Just to let you know, though, in being fair and reasonable, in some of these guides, there are some errors. I've found some references to regs that don't exist. So I think these were written to earlier editions of the regs, but I'll let you guys find them. But other than that, really, we're kind of done. We'll be doing this again on Thursday. And what we'll do now, David, as I assume, is we'll take to the questions.
We can go through some questions. Yes. Okay.
But if you want to leave now, then thank you very much for joining us.
Thanks for coming.
We'll see you again on Thursday, and we'll now do the Q&A.
All right. So shall I go with the oldest first, which goes to the beginning, or go with the most recent, which kind of goes backwards?
I'll leave it to you. You're the
all right, we'll go the oldest first. We'll just try and some of the questions are written in a way where we'll have to try to get an understanding what they're really asking. All right, we'll start with Dave Betteridge has said, if we're going to start to depart, this is talking about the SPD, I guess. The departure that we said is most likely going to be a common departure. Do we need to check our insurance for the correct cover for us to start making those decisions?
Oh, good question. I would say no, because you should be adequately insured anyway to offer informed, like when you're doing EICR, you should have.
Our indemnity insurance covers that, doesn't it?
Yeah, your indemnity should cover it. So I would say no, but always check your insurance anyway.
Yeah, yeah.
Can I just say before he does leave, I see Lee Ward in the chat.
Yes.
This is the Lee Ward that we know and love. Hello,
yes.
Sir. It's nice to see you in here. I hope you and your family are well. Sorry, I'll go back to that.
No worries, mate. Yeah. Okay. All right. So Dominic says, on unearthing on a TN system, we were putting the electrode in. So this is where we talked about, and we had the picture of the conductor talking about the additional electrode at the intake. How is that practical with services to the ground and getting them 5 to 10 meters away? So it's obviously thinking about the electrodes and other services in the ground. How is it practicable?
Unearthing a TN system, putting an electrode in, how practical are services in the ground and getting them 5 to 10 meters away? Yeah, good question, Mr. Ryan.
I cover this one. Yeah. Okay. On a TN system, it's absolutely fine, because you're connecting an additional electrode to the combined neutral and earth conductor. The distance about the 5 to 10 meters is if you're going to use it as a TT installation. And that's when you do need to make sure it's completely separated from your TN arrangement. But if you're just connecting it to TN, it doesn't actually matter about the distance to other things, because they're all connected part of the same earthing system. So that's not a thing. It only applies if you're going to say if you've got a TN system installed and you wanted to convert to a TT arrangement, that's when you would need to make sure it's totally separated and moved away from that.
Because there's a risk of inducing a voltage into the adjacent earthing system, is there?
Yeah, that's right. So
the separation's not there then.
Yeah, so you would end up with a weird sort of hybrid thing where it's supposedly TT, but actually it's not, and you've still got the dangerous voltages coming in.
Yeah.
Just to be clear here, the DNOs regularly do this, and we'll cover this on our next podcast, where when they repair networks, they will put electrodes at end of line and all sorts. So it's a hodgepodge. So yeah, right.
All right. Got a few AFDD related ones. So why only 32 amp or below? Why, AFDD, because Michael says shower switches typically can burn out.
So yeah, and I agree with you, because as I've said before on Mr. Narji's radio show, anything a plumber can touch is my guide to AFDDs. Now we should write a booklet called Anything a Plumber Touches. What do you think about it? Immersion heaters, boilers, anything that's high current using.
Good demands, good duration.
Yeah, exactly. Immersions, etc. That's the sort of stuff an AFDD would be perfect for. Showers as well. 10 kilowatt, totally agree.
I guess it's just a limitation of 62606.
Yeah, no, it's not, because 62606 goes above 32 amp.
And so why is it only to 32 amp?
Because that's what the regulations have benchmarked. But you can get greater than 32 amp AFDDs. I think they go up to 45 amps. They're specials, but the standard does allow above 32 amps. Okay. So you can get them. Whether I don't know how, I've never fitted one, to be honest with you. I don't have the electricity bill bandwidth to cover the cost of running them, but
and regarding obviously that 32 amp number, does that obviously mean that 60309s or Commando 32 amp sockets would be within its reach?
Yeah, more than likely.
Yeah, I guess so.
I'll find out for Thursday, by the way, Mr. Elliott. I'll find out for Thursday and I'll let you know. I'll put it on the next one. We'll talk about this. I'll read up on 6606 just to be clear. Next question.
Okay, actually, Ben's got a question which goes back to the TN system and the electrodes. So, can we not carry out a required test when carrying out, say, an EICR to check the difference between the installed TN system and the installed earthing electrode to check for the difference that could be hidden that we discussed? So, our hidden difference is this so that's regarding the network. Best way to do that would probably be like what you said, where you would break them down and measure them individually.
Okay, a new test when carrying out an EICR check difference between the installed TN system and the installed earth electrode. Yes, you could. There's no reason why you couldn't do that, but you need to understand electrode testing. I do it every 4 weeks if anyone's interested and fancies a trip to the M25 in Essex, where we go through it. So it's an open invite while I'm with my current employer. If anybody wants to learn electrode testing, we go through the full suite of fall of potential, clamp testing, and ZS testing.
Yeah, it's actually,
that wasn't a plug, by the way.
It's a good demonstration, though. I mean, I nearly bought a Q-Tech in sale, which is the same thing. It's that one, that clamp that puts the voltage into it.
Yeah.
I got the emails like, oh god, I nearly. Right. Do we think manufacturers are getting a pass here in terms of AFDDs?
I think AFDDs are an absolute necessary evil, but we've got to get better at understanding them and learning when to select them. They're not a blanket one fits all. They never have been, but manufacturers, I'm not going to comment on individual manufacturers.
No.
I think a lot of people in the industry think AFDDs are marketing at its best.
Fundamentally, if you install a board full of AFDDs, even like 6 amp ones, which may not really be necessary, the manufacturer's just going to like and repost that. Manufacturers do what they do. As long as the technical information that they give us is correct, then they've still got a job to do, And I mean, I can't remember which webinar I did see. I think it might have been Skullmore. They did the YouTube video, and they're just getting into AFDDs. And Jake actually did say things like light circuits probably not going to be needed. He said that, and so do look at what the manufacturers say. You may see they have different attitudes.
It was in the draft. The draft talked about light circuits not being a requirement, so that's where he probably got it from, was the draft.
Yeah. So, right.
Richard Harrison's not asked a few questions, has he?
As I'm sure he has. There's a couple. Oh wow, yeah, he's asked a few. Right. LSF. So this must be where we were looking at the protected escape routes. He talked about is LSF actually not flame retardant, though, is it? Because you're talking about
LSF isn't.
Yeah, low smoke.
No, it's just the way that it doesn't burn and give off smoke and turn into toxic charred mess. That's the point. But it will burn just as anything else does.
Yeah, there's LSF, there's LSOH, LSZH. There's different fire resistant properties.
There is a
grades.
Yeah, but there is a difference between something that's non-flame propagating, something that is actually fire retardant. There is a difference.
Whereas I think Richard Harrison is talking about if he gets a blow lamp on site tomorrow, he'll make that damn thing.
He will. Yeah,
send us a video, post it on social media, Richard. So next one, if we're adding to a circuit to a building that falls under 3 idents, but the circuit we're installing isn't going to cause any issue with switching transients, would we need a signed document still?
Yes, with the surge protection stuff. If you're adding a circuit to a building, you've got to really consider what you're actually adding the circuit for and what sort of equipment you're going to be attaching at the end of it. Now, if you're just going to put some in for like one little thing that doesn't need surge protection, fine. But on the other hand, in most cases, whatever you're going to be putting in a circuit for is going to have some piece of equipment on the end of it, which in most cases is going to cost far more than the piece of or the surge protection device that you're going to put in. So in most cases, if you're putting in a new circuit for something, you're going to be putting in surge protection regardless, because you're going to be needing it. So
right, I've stopped sharing my screen now so that you can actually see our faces a little bit better. Not that you'd want to see our faces that much.
All right. Aaron says, would you put in a £29 SPD even if it's a different brand and a CU and not type tested?
Maybe not inside the SPD, the board, but outside. I've got my board downstairs. I've got an SPD built in, and I've also got one externally, which gives me redundancy. And I've done lots of retrofits of electrical installations where the boards are existing, and we have then put in an SPD as close as reasonably, being mindful of that limitation of length of the line and CPC conductor. And some installs, as you know, Dave, have been great and successful and have captured transients, and others not so successful.
And some not so,
yeah.
Let's put it that way. All right.
Anyway, right, next one.
Okay, Mark says, well, okay, unfortunately, RCBOs and AFDs don't come obviously in type F and B at the moment. So it's obviously talking about the ideal of selecting a type F and B RCD. So at the moment, is it a separate MCB and an RCD and an AFD required, as Hager seem to be doing?
Siemens do this is where the European model works really well. They have modular devices which do all sorts of shenanigans and jazz and various bits and bobs, and you can get modular stuff, but again, it's European stuff, not yet quite available in England, unfortunately. Dare I say, manufacturers need to sell all the old stuff first.
That would
Did I just show that?
No, I didn't hear it. Right. Kevin says, do RCBOs need to be double or single pole, or does it not matter with exception of EV points?
Well,
That depends, doesn't it, of what you're installing and what type of earthing system you've got.
that's a good answer, actually.
Most manufacturers are going towards having the switch neutral, which is fine. If you put it on a TT system, then it will need to be the switch neutral.
Obviously, yeah. So,
however, interesting with EV points, you don't necessarily need to have a switch neutral RCBO if you're putting an EVSE in, because in a lot of cases, the EVSE itself has the RCD built into the device. So if you're going to put one of those My Energy Zappies in, for example, that has the RCD built into it. So you don't even need an RCD on the circuit supplying it necessarily. So if you're going to do it all in armored cable, you don't need an RCD on that. You can just put a circuit breaker there, armored cable out to the device, all the protections built into the thing itself. So it depends.
So, I mean, what is the price difference? Is it pennies? Is it between a single pole and a double pole RCBO?
It's basically nothing at all, but it depends on whether the manufacturer actually makes them or not, because some do and others don't. Those that do are generally gone to their, all of them are going to be switch neutral, and those that haven't, it isn't. So it comes down to what make you've got.
All right, Dave, how can you test a circuit with installation of connected equipment constitutes to the circuit, such as integrated downlights? For example, IR of 500 volts.
I'll answer that one. When you put in your integrated downlights, you fit them using a plug and socket connection.
Yep.
So you do your first fixing with the plug or socket in the ceiling, and then when you come to second fix, you just plug them in after you've tested your insulation resistance.
It's like you can get those plug-in click, if you're doing like, if you have like recessed seams, you have those plug-in click roses or anything, and you can just unplug them.
Or you just stick them all on a load of Wagos.
Or a load of Wagos.
And basically bell them out and then go around and do your second fix.
The key thing is the timing of that Don't do it at the end. Get your your cables wired up. Get your connections done, and don't put your loads in.
That was a good question, Mr. Gill. Very good
The
question.
plug-in ones are ideal. I mean, I think like Greenbrook make them, but they're so much easier when it comes to fault finding as well, because you've got one that's faulty, unplug it. Oh, all the lights work now, and just get a new one.
Yeah, lots of different configurations.
Okay. Mark has heating appliances can have an installation resistance test less than 1 megaohm and still pass, as further tests must be carried out as shown in the testing code.
Ishiti.
Yeah, the ECT copies this.
Can have an installation resistance less than 1 megaohm and still pass.
Let's just have a load if we have loads connected.
Okay, so my Ishiti knowledge is quite poor because I'm still working to the 4th. This is the fixed installation here, not necessarily the connected appliances, but this would get, surely we would just be disconnecting at the isolator and not.
I would assume you would have a fuse connection unit and you just switch that off.
Yeah, that's what I'm assuming, but that's a really interesting point, Mark, because I didn't know that, so thank you, sir.
Or inconsistencies, which is no surprise at all.
True. Yeah.
Heaven forbid. Chris Ruddock, are we still adopting maximum 200 milliseconds of BS4293?
Well,
that table's gone. Is 4293 even in it now?
No.
If you find a BS4293 RCD and you want to test it, then in theory, yes, it's still 200 milliseconds because that standard hasn't been updated.
Yeah.
However, if you get an installation with a 4293 thing in it, is it really fit for purpose anymore? And the answer is no, because it's going to be a type AC and it's not going to be connected to a heater, and it's
Well, that's it.
So
since AC has basically been phased out, then so are 4293. So if you've got any 4293s, they're no longer technically C2.
I'm just going to quickly look in the on-site guide.
I'm being quite harsh with my C2s tonight, but I've spent the last 2 days reading this sodding book title to.
Yeah. Okay.
Yeah. So either way, they do not comply anymore. So in the bin.
In the bin.
Yeah.
Right. Next one. Can you confirm BS? I avoided this deliberately. BS7288 SRCDs are back and compliant for additional protection, Mr. Watts.
They have basically said yes, they got it wrong in 7288. It wasn't as intended. They are now okay, but they still must have protection upstream.
Okay.
Basically. So we're basically saying, right, you got that wrong. That didn't work. They've now said, oh, we didn't mean that. We've changed it, which is great for a technical standard. And that's it. Do they? I mean, do they have a purpose? Do you achieve selectivity with them?
No. You can use them, but they have no purpose. And also consider what type of RCD they're going to have in these sockets and FCUs. Guess what? It's going to be a type AC, isn't it? So they're completely useless.
Well, no.
So yes, you can use them. But
Green Book now do type A only.
I'm not buying that.
Learning. Although you are right, it's pointless having a type A socket with a need to have everything on the board of a type A LCD. So they are effectively pointless.
I've just looked in the on-site guide. Damn you! Because
Well,
probably one of the first times I'll look into it. Yeah, this is probably just as new as my old one. It does have the mention of 200 milliseconds for 4293s in there, but that's obviously existing situations. As John says, if you're going across that on a new thing, you've sold some old crap. That
and the other bits just had on there about there's no selectivity between them because they're the same rating and they're not time delayed. So basically, they're going to fail on a whole load of other points anyway. So they're kind of pointless. So in theory, you can use them, but in reality, no one cares.
Okay. So. Richard's got another one. Test installation resistance on a minor works. So testing the whole lighting circuit after our addition. Is it not acceptable to limit the live to neutral and test between live and neutral linked to earth at 250, then up to 500 volts, or just do it at 250? Right.
Testing installation of minor works. So testing the whole lighting circuit after our addition. It's not acceptable to lim live neutral and test live up to 250. So I would suggest your new stuff has to be done.
Test your addition between live conductors, insert your luminaires, then connect the whole thing and test between line and neutral of that at 250.
And if you ain't got 1 meg, you're in trouble, regardless.
Yeah, just remember that you're testing, if you're putting additions in, you're testing the additions. You're not there to test the whole rest of the installation and make sure it's all up to the standards and all that. So
can I say one thing publicly? I love the fact that Richard Harrison asks questions because there's no such thing as a bad question.
Huh?
Unless you're Richard.
All right.
Thanks, Richard.
Okay,
Well,
Dave.
Andrew Brown's just put on, what if it's an AICR? Well, if it's an AICR, that's not initial verification. So that particular bit in 64 does not apply because that's 65. So there we go.
Indeed, Mr. Betteridge, who's he? 64331 gives 2 points worth of read, allows the line. Oh, sorry,
He was replying to Richard. He's gonna he's doing our work
So-
for us. He's gonna come on and do one of
doing
these.
our work.
What are you doing Thursday, David? Come on, what are you doing?
What are you doing on Thursday, Betteridge?
Get your mic set up.
Yeah.
All right.
Mr. Harrison, high integrity sockets have now been removed. However, we've designed the circuit to be less than 9 milliamp. We cannot control what is plugged in, so therefore more than 10 milliamp can be present. So maybe best to overkill and utilize high protective earthing. However, if we're going to install duplicate CPCs for this measure, why would dual terminal sockets be removed to eradicate the issue of a lost CPC? It's a really good question. And if I refer to my Paddy friends over in Ireland, they require that you know what the connected load is for, or you design for it. But it doesn't really matter to a certain extent, because the RCD nuisance tripping, it's nice to not have nuisance tripping, but if you can't prevent it because you've been called out, you've put your clamp meter on, it's 24 milliamps, and that device, you do a ramp test on it and it's 24 milliamps, then of course it's going to trip. There's nothing you can do about that. It may be a faulty appliance.
The best thing you're going to have to do really is think of 314 division installation, many RCBOs, and many maybe even radials, so that you have fewer sockets on fewer circuits. You know, that might be where we end up. We may even get rid of the ring final. Dare I say it?
What a good idea.
Yeah.
Get rid of them tomorrow.
Well, I don't acknowledge
Anyway.
the existence.
Chris says 728, 200 milliseconds too. Good observation. Yep. Thank you, Chris. Yep.
Another reason why they're obsolete and should go away.
So, Mr. Wayne Rodis Clark, we do a lot of installs on caravan parks. The SWAs are normally installed by the groundworks and not us. Oh, Jesus. This seems to be pushing us towards needing to carry out 500 volt IR and then 250 at second fix. Is this how you would see it? Yeah. Absolutely.
Yeah, pretty much.
Yeah.
Bang on, Wayne. Yeah, totally agree with that. And Stuart Eversham, you have mentioned the ICR coding a few times. Obviously, we test and inspect current regulations and code accordingly any differences. Is there a recognized time period after the regs come out and that coding would go from a C3 to a C2? No, I don't. Well, in my opinion, no. E.g., most people would agree now that domestic sockets without RCD are a C2, but lack of RCD protection in walls, for example, will always create a debate, C2, C3.
Mm-hmm.
Yeah, it is. Do you know what, Stuart? Brilliant, because if it's in the zone, it will always be a C3 for me if it's within the zone. But the trouble is I don't know. And I can't code what I can't see.
It depends on who's using the installation for me. In a commercial, industrial place where people have permissions to break, build and fabric and do things, there's levels of instruction, information, training, competence and all that stuff. In the home, there isn't ordinary persons. So I would C2 a home and C3 a workplace. Don't forget that Mary Wary died because of that.
Yeah.
A lot of this C2, C3, yeah, I mean, it's coming up because, particularly in domestic, there seems to think, oh, we can't put C2 because then they'll have to have a new consumer unit.
Yeah.
Well, in many cases, they need a new consumer anyway, because what's in there is 25, 30, 40 years old, and it should have been replaced by now anyhow.
That's the other problem, though, is the coding's too restrictive. I think I've said that so many times.
Just also to be clear here, RCDs have a life.
Mm.
These electronic protective devices have a life. It's not like the old MCBs or fuses where you can leave them there for 30, 40, 50 years. RCDs are electronics. They have a shelf life where their performance capabilities will decline. And that's something we don't talk about enough. So Dominic Ryan, going back to TN Earth and 5 to 10 meters, how will islandware work on a terrace street? How can you achieve the distance? Just look for the steam in the street. It's a good question.
Get your thermology camera out. Look at the warm spots.
Go on, John. How will islandware work on a terrace street?
That one, if you're going to use a TN Earth, which is what comes to the grid, it's not a problem because that 5 to 10 meters doesn't apply. But if you're going to have a TT arrangement in island mode, if you're in a terrace street, that isn't going to happen. So you'll have to design it to be a TN system when it's in island mode, which raises a whole load of other possibilities, because then you're going to have the earth and neutral connected in your inverter output and all kinds of other problems. So yeah, TT in a terrace street, unless it's all TT, is not a thing, and it can't be, because obviously you're not going to be the right distances away.
IoT Code of Practice, there's some very interesting documents out there, and I'll be honest with you, I read one the other week and it blew my brain up. Richard Harrison has asked another question. You get the record, Richard. I was saying when we leave the job, there could be more than 10 milliamp. Well, if there is, then you haven't designed the installation correctly, have you? The earth could be lost, and this lies the issue. You could have 14 milliamp, for instance, sat there on a class 1 equipment when the earth is lost. Well, okay, 40 milliamp necessarily going to sit anywhere. Then relying on the RCD tripping when someone touches the equipment, the high integrity earthing is there to give another path back. Richard loves high integrity earthing.
He does, yeah.
I mean, if you want to install high integrity earthing, go ahead. But the point is that it's now been said we don't need it. But
if you're producing circuits more than 10 milliamp, you're failing to meet the intent of the regs anyway. If you're failing to meet the intent of the regs, you're departing, which is okay, because remember what I said at the start, it's a guidance note. You have to have a defense in front of a court of law. You have to consider utilization and the people using it. You have to use your brain. You have to use your conscience.
You know, I mean, you know the limitations to 9 milliamp, and if you know you're going to have equipment that's going to give out more than that, then you know you've got special design consideration to go from that anyway, so you can then expand on it and do what you need to do.
Oh dear. Okay, so this is the question from Mr. Brewerton. I posted a question in the IT forum a couple of years ago mentioning reactance for ZS, which Dave spoke about.
Yeah.
Measure. The answer given was for circuits below 63 amp, don't worry about it.
Well, a very long time ago, that may have been valid when it was all resistive loads, but that is not valid anymore because resistive loads pretty much don't exist anymore. So,
I'll give you a great example. A very long time ago, some genius thought it was a great idea to put type A CRCDs on a railway with 750 volt DC, and then wondered why nothing ever tripped out over 30 years, because they wouldn't trip out.
Yeah.
We only ever know when something goes wrong. And I've never agreed with resistance and impedance, which are two totally different things, being put together in a formula and working out. It just doesn't equate to me at all. Never has done.
No.
And there is a certain person who says no quite a lot that we know.
No. Yes, we do.
I believe has written a paper on this as well.
He has, I think.
Yeah.
All right. Well, the questions have dried up. Are we done?
That's it. That's done. So that's us. If there's anything more in the chat, let's just look at everything. If my computer is working, I can't see anything. Other than that, really, the whole point of today was for us to share our knowledge, to spend a couple of days of our life mining this document, giving you independent facts and data. We are not the single source of truth. This is an opinion. We are free friends. We have an opinion. We're sharing it with you. We're debating it live. What we're saying isn't gospel or doctrine. However, I would like the people watching this to go away thinking, I am the decision maker. I'm the master of my own destiny. Go away and research. Go away and mine those sources of information. Ask for help. And yeah, other than that, I've got nothing else to say other than to thank Mr. JW and Mr. Watts and everyone else for attending.
Yeah, there's a couple of other bits just to wrap up there.
Okay.
Chris Roddick's, but it's surprising how much LED lamps affect the loop impedance readings. Yep. And if you go to any installations with solar or any kind of inverter equipment, do the readings with and without it connected and see what kind of differences you'll get, because I'm not surprised. And then there's just one other thing here. Connor Sun has got, how long have we known about AC RCDs being blinded by DC? Well, the answer is Germany's known about it for 40 plus years. So, yeah. Covering it up and putting it under the carpet.
I wrote an article on LinkedIn, which I was mocked and abused for many years over. But hey ho, bring it on. Plenty more stuff to mock and abuse, because, and I'm going to do this very quickly. Wait till you see these bad boys. Anyway, there you go.
Okay.
What a tease.
What a tease. We have more weird and wonderful stuff to show you. So there are going to be podcasts coming where we're going to introduce you to, we're going to talk more about G12 and DNOs and earth loop impedances and the maximum values for that. And we're also going to introduce you to a brand new device that nobody's ever seen before.
Yes.
Ever.
All right.
That's it.
You're hosting, dude. You got to wrap this up.
Oh, I've got to close this now, haven't I was wondering.
Yeah, I can leave, but you can close it.
So everybody watching, thank you very much.
Cheers, guys.
And we'll see you on Thursday. Take care. Bye-bye.
Bye-bye.
Right. So I have to. And no.
End for all.